approximate size? Yes or no?
Yes.
Suppose I buy a size which is, I give it to the tailor and tailor says, sir, this is not for your shirt, this is for your handkerchief. The item that you have get me is only for your, probably I can make a handkerchief for you, not a shirt for you, definitely. Then what it will be? Measure face, very important, right? That is what you are going to do. Measure face introduction is this only. I have defined the problem. Is that problem is measured correctly or wrongly? I tell you that, sir, I have a problem, sir. Right? I will say that, sir, Bhavani madam does not know anything, sir. But then Gopal Chaudhary will come and tell, hey, Bhavani madam is a professor, right? She has got PhD in so many subjects. And you are telling, then I will realize, I have asked a wrong question. I did not know the answer. Without knowing the answer, I have asked a question. Based on that, I have made a judgment. So what should I have done? I should have taught first. And then I should ask a question for which I also know the answer. Yes or no?
Correct.
This is what is called measure face, right? So we have identified the problem. There again, I got a question. Why identify a problem? Are we have to going to identify the problem? So many problems are there, and I have to identify one of them. Which one? What is this? Is this a step, right? Going on looking where is the problem? Where is the problem? No. This is what I teach you. Identify problem, select the best problem, use a Pareto chart and things like that, right? But the problems will automatically come. In real life, what will happen? This is not the step. In real life, no, so many people will be making shout. My son will be saying that, sir, Abba, I want to go for excursion. My mother will say that I will go for a, what do you call, then traditional tour, no? What do you call, what is it called? Visit to temples, right? And then my wife will say that I want to buy sari for my sister, right? Yeah. All these things, which is the problem, which problem I should attack first, right? Problems will come on their own to you. You will have to identify which problem I should attack first, so that the other problems, we will wait for some time. Before that, I will be free to attend to all the problems. All the problems will have to be solved. In real life, what is the answer? All the problems will have to be solved, right? Don't say that later on, RK sir taught that we'll have to identify the problem, only select the best and then solve it. No, that is not the solution forever. The solution is you have to solve one by one everything. The order is what is mattering. Understand? Clear? This is not a part of the course material. Please note, I'm just telling you this out of experience, and then out of experience, purely out of experience, right? And then, so you have identified the problem. The problems, that is why, the voice of business, voice of people, voice of customers, you see, they come automatically. And then you'll be able to, it is a very easy job. Brainstorming is there, Pareto chart is there, cause and effect diagram is there. So many things, tools are there. Mind is your tool, first tool. Right? Then, after identifying the best problem, then what you should do?
Control.
You should carefully approach. You should not straight away start solving the problem on your own. Because if there is a problem, then Bhavani madam, who was my boss, she will fire me. Yes or no? Right? You are no fit. Right? Who gave you the permission? They are the boss, right? So management approval is required. So for management approval is required what? Now, I will not ask my wife for any food to be prepared. First of all, I should know which food, if I say, she will be happily accepting. Upma, if I say, she will be happily, okay, I will do it. If I say vegetable biryani, then who will have time for buying the vegetables, then cutting it and all? She will get annoyed, right? Go to hotel and get it. I will not do it for you. That's all. So boss ultimately matters. What the boss will be thinking, you'll have to think that way. Is it going to be helpful to the boss? A boss is employing me, paying me 1 lakh rupees per month means I must be able to provide him 2 lakhs per month. Then only he will give me 1 lakh. He will be able to give me. Right? Yes or no? Right? So we should put ourselves, empathy, they call it empathy. Put ourselves in their shoes and then analyze the problems. What are the problems we will have to analyze? Is there a problem really existing? Is this problem solvable? Right? If this problem solves, will it be helpful to the management? So will the management be willing to attend to this problem? Will the management be able to provide me the resources required to solve the problems? So protect myself. What are all somebody has given this management, what do you call, project charter. I gone through that. I did not go through that, but I just gone through that only one PDF, no, just 5 seconds. And risk, no risk. Don't put no risk. Project charter, never put no risk. Okay. You are not, we are not supposed to say there is no risk, right? You can say and put in any other way. Risk is always there. Right? Risk is always there. We will not know whether we will be there tomorrow. Yes or no? God has given us, no, that provided us, okay, live. He may take our life anytime like. Therefore, so be careful in providing your project charter. There is no risk, don't commit that. Right? Just like that, we want to talk to somebody, talk something good about them. Don't talk bad about them. Similarly, here if there is a risk, risk is there, provide. If there is no risk, don't provide. Because we are protecting ourselves there. Yes or no? Right? Then they will say that you said there is no risk. See, here there is a risk. We are going to lose now. We don't have market now. Because of you, we have made the production. Million production is there. Who is going to buy that? Right? You said that you are going to solve it, you are going to increase the production, but it is not, it is lying as inventory here. This is not a risk. Therefore, there is always a risk that whatever you produce is going to be sold and then you are going to get the revenue. Yes or no? By merely solving the risk defects, I am going to solve this defect, but there is going to be another defect produced because of this. Then this is not a risk. Right? Therefore, protect yourself. That is what is called the final statements, no? In that 6 body packs are there, no? 1 pack is that. You put your assumptions, availability of resources, and then market fluctuations, if they are there, they are considered, right? I have considered this is the raw material price. I have considered this is going to be the increase in market, right? Because I assume that there is market potential for absorbing this increased production or this modified production, things like that. So always think that way, include those things, right? This is nothing but a preventive action. Project charter is nothing but a preventive action, right? Okay. And business case should be there. When will the business case be there? The business case will be there if they see money in that, right? How will they get the money? Who is going to give the money? You are not going to give the money. Ultimately, the customers are going to give me the money. Is this not a risk? Or the customers under your hand? Clear? Yes or no? Though, and project charter is a team effort. You can't do it all by yourself because you need to have the financial background, right? I have done cost accountancy, but I can't say that I have made this financial accounts for this, financial budget for this. Is okay or not okay, right? Who knows how to calculate this, what do you call, current, what is it called? What is it, yeah, financial budget? Net present value, NPV, net present value, or that which project is better revenue provides, some things like that. Rate of return and things like that, you should know. And then legal point of view. I may say that I'm going to use this raw material. That raw material may be prohibited. That particular customer may not allow that raw material to be used. Yes or no? These are all the things in project charter. Therefore, once you identify the problem, you are making a project charter wherein problem statement will be there and then goal statement will be there. Goal statement should be smart. It should be possible to achieve, right? And business case should be there. And then scope statement should be there. Your team members should be there. Your considerations. What is the consideration? The considerations are the risk and other things. Now, I have stated the problem. What cannot be measured cannot be improved. Yes or no? What cannot be measured cannot be improved. Therefore, there must be a metric. And the metric should be measured properly using the appropriate gauge. Clear? So this metric gauge and the gauge should be used by the appropriate people. The person, the gauge, and the object together comprises of this measurement system. Yes or no? right? I want to have I want to measure the length of a particular object. I must use a gauge, screw gauge or a vernier or a scale or a tape. Where I need to use a tape, I can't use a gauge, right? I will tell you an example here. I was working for an export. We are manufacturing big turbines, big shafts, 1 meter diameter shaft and all, steel shaft, stainless steel shaft. Lloyd's inspection, third-party inspection. Then for that there will be hub and all, which will be matching part. Matching part will be made in Ahmedabad, and then the shell part will be made in Chennai, and things like that. And then the material will have to use the same material because all these things are there. So for the material, we know we buy sheets and then it will be stamped there. And if I cut a piece, and then I will put my seal in a stamp in another part, which is uncut part. So cut part will have the stamp. It will be used so that we know that the same material is used, and the uncut portions will be there. Whenever material is required, I'll put this. But then the dimension, I'm going to use a tape because the diameters are the order of more than a meter. No, I'll use it. Large inspector came and then he will not take anything, no bribe, nothing. He will not take even lunch there. So I will come there morning before lunch. We'll finish it up, go asking how are you going to ensure that it is going to be matching. The dimensions are same as per the drawing. What is the answer solution? Do you know? Can anyone tell me what is the solution? I am the local inspector from my side, from the side, right? Fabricator side. Sir, I am going to use this tape only. Then I will be using then they what will be using then I do not know, sir, what to do because I'll be using the no. Have the same tape. You have the same tape, and wherever you want to go and measure, use the same tape and then measure it and then okay, inspect it. That's a very easy, simple solution. Yes or no? It is not that has to be the same dimension. This has to be the same dimension as per the drawing. No. As per the drawing, you are measuring it. It's okay as per this. And use the same tape and then measure it there. It is matching or not. As per the drawing, it will be all right. So solutions will always be simple. Be it Lloyd's inspection or be it any third-party inspection. The solution will be there and simple and it will be accepted. Right? Okay. And measurement system analysis is the same thing. What we have to measure, whether the gauge is okay, current gauge we are using. Gauge is capable of measuring this, the deviations. And then the person who is using the gauge is capable of using this gauge and telling the same thing, repeatability. And if there are 2 or 3 persons using this gauge, are there any differences between their opinions? Are they, if I say 2 mm, the other person also says 2 mm or not, right? This is called repeatability and reproducibility. Suppose I say that it is 2 mm today, the same item tomorrow also I'm saying it is only 2 mm, and then I'm repeatability. I have a good repeatability. If I say 2 mm, my colleague Gopal Shukuman also says 2 mm on any other day for the same item using the same gauge, then we have a good reproducibility. Then we form a good team. If you ask a question about, somebody was asking a question about the cost of poor quality, right? Cost of poor quality, please note that I don't know who was asked. This cost of poor quality is nothing but wherever you spend money for poor quality, that is cost of poor quality. Like you are spending money for repair, right? That is cost of poor quality. For
re-inspection is also poor quality.
Yes, that's all. There is nothing like he was mixing a term assurance cost. No, assurance cost is something different, right? You are giving a cost for insurance cost, right? Insurance cost is nothing but term insurance is there. They pay and I don't get any money back for that. But that is a cost involved. That's all. Once that is neither a cost of good quality nor a cost of poor quality, in my opinion, right? Maybe cost of good quality, you can say that because you are having a peaceful life. Because something happens to me, my wife will be taken care of, right? But this money will not come back to me. Right? So I think I can call it as a cost of good quality, insurance cost, assurance cost, and things like that, right? Otherwise, cost of poor quality is cost of quality, good quality should be less because you are doing it right at the first time, right? So you are measuring it right at the first time itself. Otherwise, no, you are measuring and then you are measuring using a wrong gauge and then everything goes awry. You will have to again do the problem same again. Right. Therefore, in measurement system, I will, in fact, I have to show some slides. No, Gopal Shokmar told me to show the same slides. Let me show the same slides there. Can I see that? Oh, 920 is to come now. Anyway, before that, I will try to show the 3 slides. Can I show the slides, sir? Yes or no?
Yes, yes, yes.
Yes. Yes. Slide show from current slide. Yes. Measure phase, toll gate review. Measure phase, steps and main deliverable. Now, the main deliverable is the gap. What do you mean by gap? Nothing but we know what is the performance. What is the current performance? We have already fixed what is the expected performance. Yes or no? Right? The difference between the two is called gap. I scored 30 marks now. And then you are giving me an exam. Next time my object is to score 70 marks. What is the gap? 30 marks I'm scoring.
40.
40 is the gap. That's all. That is what we are going to find out. What is the gap? How much we have to improve upon? What is the Z score? We will have to increase by. And measure steps are, first thing is fixing the CTQ, performance CTQ. And then the measurement system analysis, that is get the gauge R&R. Gauge R&R gives you whether the system is okay or not okay. That means the error that you are going to get in your measurement system is being measured in the gauge R&R. It should be only 10, maximum 10%. It should be only 10% maximum. If it is more than 10%, if it is up to 30%, Baba, try to use it at present, but try to change it within a month or within 6 months. If it is more than 30%, at any cost, don't do this. You will have to stop proceeding further, get the measurement system perfect, then only you should proceed. Understood? The main deliverable is, okay, the performance level, baseline performance. We are going to measure baseline performance. And gauge R&R is a measurement system analysis. Gauge R&R should be less than 10%. If it is less than 30%, okay, but try to change it soon. If it is more than 30%, do it right away, change it. You are not allowed to use this measurement system. And steps, the steps we are going to measurement phase steps is first is critical CTQ, fixing the CTQ performance level, and then measurement system analysis, and then baseline performance. Baseline performance you can measure in 2 ways. One is 2 cases. One is for continuous variable, another is for discrete variable. One is for qualitative, another is for quantitative. These 2 types of baseline performance. For all these things, we will give you a template. You can also get the template from me, and that template will be useful. You can use it for your lifetime. Okay. Have you identified the CTQs to be measured? That is, we say yes. Do you have an appropriate data collection plan? What is this data collection plan? You will have to, first of all, what is that you are going to collect, how you are going to collect, who is going to collect, where you are going to collect, when you are going to collect. All these things you have to tell this. Right? You measure the temperature, and you measure the temperature always at night time. Right? Then it may give you a wrong lead. Is your measurement system capable and adequate? Right? So this, I have to use the correct gauge system. I should not use a overrated or use an underrated gauge. I can't use a scale to measure 1 meter, 3 meters, right? So I can't use a 3 meter scale to measure 2 mm and 0.5 mm, right? Like that. Is the data collected appropriate for analysis? And you will have to find out the data that is useful for you. And the data should be in the correct metric. Suppose I want to measure the quantity. Somebody will measure it in volume, somebody will measure it in weight basis, somebody will measure it in grams, somebody will measure it in pounds. This thing should be avoided. That is what we like to say. The data collected should be appropriate for analysis. uniform, consistent, and then can be used. How far is your project goal from the current performance? This is the gap, right? If you want to improve, I want to improve my marks to 70. You all said 40 is the gap, but my current level itself is 80. Then is this goal correct? My trying to get 70 marks when I'm already scoring 80 marks, right? So this is not appropriate. Therefore, I will have to put the gap as plus 10. 90 marks should be my aim. Therefore, in this measure phase, we know what is the gap, and if the gap is inappropriate, we can make it appropriate and then proceed further. Clear? All of you?
Yes, sir.
Somewhat?
Yes, sir. Yes, sir.
Yes, sir.
Yes.
See, the energy of one person is high or energy of 10 persons are high.
Yes, sir.
Thank
Energy,
you.
10%.
Yes, sir.
I understand. Thank you. Right. So data collection plan, validate measurement system. These are the steps, right? And then measure the baseline performance. These are the three things you are going to get in this measurement phase. Main deliverable is baseline performance, right? And then the CP, yes. Data collection plan should have operational definition and data type, continuous data or discrete data. Measurement system validation, we will know the terms bias, repeatability, reproducibility, age R&R. I have already told you what is repeatability and reproducibility. Repeatability is for the same person, reproducibility is for a group of persons. Bias is there are two types of bias, right? We will see that. One is called linearity, another is called stability. Over a time period, over a range, right? Over a range. Like for example, I want to measure 10 meters and the error may be plus or minus 1 centimeter. I want to measure 100 meters. Then the error may be same or it may be different. Yes or no? Right. For 10 meters, the error may be 1 centimeter. For 100 meters, the error may be 5 centimeters. Right. That is called linearity. And then today the error may be 2 mm. After 1 year, the error may be 5 mm. That is called stability over a time period. Wear and tear. Right. That is called error due to the time period and the range. And then measure baseline performance, traditional yield, first pass yield, rolled throughput yield. All these things you will come to know what it is. Traditional yield is fooling us. Like for example, you are giving me a job. I make 100 items and you feel happy. But these 100 items, I have made only 80 items I have made first correct. 20 items I made it incorrect. Then what happened? Afraid of you coming and checking me, I repaired it fast. I reworked on it, 20 items. Now, did I do a good job?
No.
Did I do a good job?
No.
Yeah, that is what you will find out in the first pass yield and rolled throughput yield. And DPMO is defects per million opportunities. What is the defects per million opportunities we are aiming for in Six Sigma project? It is 3.4 defects per million opportunities. That means if there are million items produced, only 3-4 items should be defective. Out of million, please note. Right. So that
Sir,
is
Naveen here. Can you just repeat on the rolled throughput yield, sir? Sorry, I
rolled
didn't get.
throughput you will understand a little better, sir. For example, I'll tell you 100 items I'm making. In that 100 items, 20 items were actually to be thrown out. 80 items are only good items. But 20 items, I repaired it.
Okay.
Made it perfect by doing work on it. I spent more money on it. I spent more labor on it. Who will pay for this extra money paid for it? Yes or no?
Right, sir. Right.
Right? That is called first pass yield. Rolled throughput yield is the same thing will be repeated in different processes. Yes or no?
Okay.
I'm not the only person making the object. I will be only the production department. There will be somebody in assembly department. There will be somebody else will be in a painting department. In all these cases, the same thing will happen. Yes or no? So
Right.
throughput yield consists of different stages of the process. Okay.
Right, sir.
Then you will be able to understand, you will be able to, you don't have to do anything, feed the data, you will get it, all these things. Don't worry.
So one question, this roll throughput, it is also can also be called as FPY, first pass yield. It's one and the same.
Yeah,
I'll
yeah,
give you
yeah.
clarity, sir.
Not rolled throughput yield is nothing but if the process has only one step.
Okay. Okay.
Right? Please note, my efficiency is 90%.
Okay.
Your efficiency is 90%. What is the total efficiency? 0.9 into 0.9, 0.8. Yes or no?
Yes.
Right? That means I can only multiply efficiency. And now can I say that, sir, my inefficiency is 0.1 now. Your inefficiency is 0.1 now. Multiply, sir, 0.01, sir. So inefficiency is only 0.01. So efficiency is 90%. Can I say 99%? Can I say that?
No.
I cannot say that because
No.
my inefficiency, your inefficiency will only add up. No, it cannot go
Right.
down. Therefore, efficiency only will have to be multiplied by, and therefore, first pass yield, my first pass yield is 90%, your first pass yield is 90%. So total rolled throughput yield is 80%. Clear?
Okay.
So you only will have to multiply the first pass yield and get the rolled throughput yield, not the inefficiency. DPMO is defects per million opportunity. Sir, this is only introduction, sir. Don't worry, sir. This will be explained in detail in the class.
We will have some example on the roll throughput yield.
Yes,
Okay.
I am
Okay.
conducting a class now. Afterwards, who is going to conduct? Gopal Shivakumar.
Okay.
Right? Whatever 90% of what I teach will go to you. 90% of what he teaches will go to you. Totally, how much what he teaches will go to you.
Okay. Sir.
Yes,
RK
sir.
sir, see
Yes.
the exam questions are completely different from like only you're giving us this PPTs, right? So is there any study material for us like we can study and give our exams? Because only this
Okay, who
PPT
is
will
speaking?
can.
Who is speaking?
This is Pamni sir.
Omni, please
Okay.
note, he has provided lots of material.
Mhm.
rksr.com. Click.
Okay.
That's all.
Okay.
Okay.
Okay. Thank you, sir.
So DPMO, CPCPK. That's all. Thank you. I think I have shown all the objects. These are all the things. Oh God, how do I close it? Yeah. Option. I think I have given you enough examples. You ask anything, madam. Can you share the template for calculating? Everything is there, yeah. Everything is there. I'll give you definitely. I will give you in this Thursday. This Thursday class I will not miss, or you can contact me anytime. Right. Any other doubt if you want, you can ask me. Any other doubt? Yes, sir. Yes, gentlemen.
In yesterday's one assessment which was given as a mock test,
Yes, yes,
sir, in that there was one question for DPMO.
yes.
So can you explain to us, sir, because I was not able to have a clarity on that, how to go about it.
DPMO, we are going to teach you, sir, defects per million opportunities. We will tell you how to calculate, and you don't have to do anything. Everything will be calculated by the template and give you the answer. Don't worry. And
Okay,
what is this DPMO? Like I'll tell you one thing. See here, normal distribution. You all know what is normal distribution? Yes or no?
Yeah.
Yes.
Normal
Yes, sir.
distribution has got a mean, average. Am I right?
Yes. Yes.
Normal distribution has got a mean. And then towards the end, on either side, extreme ends, the quantity produced will be less. Yes or no?
Yes.
Right? What is produced in the mean, that is at the middle, is maximum number, and the maximum what you want. Yes or no?
Yes.
Like for example, you want to recruit a person. You want to recruit a person, you have fresh graduate. Fresh graduate. Yes, there are people who have scored 70 marks. There are people who have scored 95 marks. There are people who have scored less than 30 marks. Yes or no? Understand? Now you are able to visualize that the normal distribution here. There are people who are scoring less than 30 marks. There are people who have scored more than 90 marks. There are people who have scored between 30 and 90 marks. Yes or no?
Right.
Now, the question is, you want to select which person for your job? Tell me, you want to select a person who has scored more than 90 or less than 30 or between 30 and 90?
More than 90.
More than 90. You are collecting, you are paying, I will tell you my experience. So I pay him 10,000 rupees per month salary. And within 1 month, he got another job because he is a very brilliant student. No, it's easy for him to get a job. So he jumped over. So again, another person I recruited having more than 90 marks. So I have spent 12%, 12 into 10,000, 1.2 lakhs, and I did not get my job done. Now tell me, who will you select? Less than 30 or more than 90 or between 30 and 90?
Between 30 and 90.
Between 30 and 90, very good. I will not select less than 30 because he will be of no use for me. Even if I spend, he will not be able to learn this. Therefore, I will not select him. Therefore, this is the people I want. These are the two extreme sides. These are all defects as far as I'm concerned. Less than 30 also is defect. More than 90 also is my defects. Clear? Understood?
Yes,
Yes
sir.
or no?
Yes.
Yes.
Yes,
Yes.
yes.
That is what is defects per million opportunities. Total million people are coming. I will remove this DPMO. I don't know what is my process level. Thank you very much. You will know more on this later, right? You will have a very clear picture later on. Don't worry, right?
Sir, even CP and CPK will be covering later, sir.
Everything will be covered, I say.
Okay.
Vinayak Murthy, you will be covering, right? I'm sorry
Right,
I
sir.
could not come on this Thursday. This Thursday we will definitely be there, 9 o'clock. And then only I will, half an hour only I will leave it to Gopal Shivakumar, even if he demands.
Okay, sir. Thank you.
All right. So, good morning, all of you. I think you had
Good
some,
morning.
very good
Morning.
morning.
Good morning.
So you had some good recall of your learnings, plus the introduction to measure phase. Okay. So definitely some questions will be tough for you in the measure mark question because we have not covered the topics. So that will be, get cleared today. So before I take you through the measure phase steps, the tools and techniques, first of all, we need to have some idea on the statistics because we are going to deal with the data. So the science of dealing with the data is known as statistics. Hope all of you know. Whether you collect the data, or you tabulate the data, or you visualize the data, or you analyze the data, or you summarize the data, or you finally interpret your conclusion. All of these steps together or separately is known as statistics. And statistics can be used to understand what is currently happening in our workplace. Then it is known as descriptive statistics. And the same statistics can also be used to understand what will happen if we continue in this manner. If we continue in this manner, what will happen? That is known as inferential statistics. That means you can use numbers to understand the present, also the past, which is descriptive. You can use the number to understand the future, which is inferential statistics. Where from the number come from? The number is nothing but statistics. So by now all of you have the clarity, right? When I calculate average, that is a statistics. When I calculate variance, can I call variance also as a statistics?
Yes.
Yes.
Right? So I sum all the number, that is also a statistics. I find out the biggest number, that is a statistics. I square all the number and then add them together, that is also a statistics. Any operation I do with the numbers and then the resulting number is known as a statistics. And we have different names, mean, median, mode, etc., etc., etc. And where from the statistics come? Statistics come from the data only. And where from the data has come? Come on, please. Where from the data is coming?
Taking from the sources where we did, either you by measuring it or by collecting it or.
Yeah. We measure it or collect it from the process. Or sometimes you measure from the product. But eventually we try to understand the process because the product itself has come from the process. So from the process, you get product. From the product, you get data. From the data, you get statistics. So any problem in your process will obviously affect your product. Correct?
Yes.
And if your product gets affected, then your data will get affected. If your data gets affected, then your statistics will get affected. All of you are able to understand the linkage here.
Yes.
So in statistics, there are too many statistics. You don't have to study everything. You only study two things. See, this is how we also work, when we want to understand something, we just try to ask only few questions. Let's say, for example, you have a beautiful bungalow. So we want to understand the bungalow. So what do we do? What do we ask? We simply ask, what is the land area? Am I right? What
Right.
is the built-up area? How many rooms are there? Isn't it? So these are the questions. So with a few questions, you try to understand the nature of the complete bungalow. Even without going inside, you will have some understanding. Am I correct or not?
Right.
The same manner, without actually going through each and every piece of data, which is also impossible, with the help of the statistics, you can try to understand the complete data, which is nothing but population. So when I say population, what is it actually? All the units that are going to come out of your process, if I put all of them in a big box, that big box is known as population. Am I correct? You produce product. Imagine you have produced everything and everything is now placed in a container, and that container is known as population.
Population.
Will you be able to see your complete population?
No.
We produce, sell. Some of them we have already sold. So together, all the unit, you will never be able to see it together, isn't it? So seeing a population is a rare event. You can only judge the population. Only to understand the population characteristics. We look at statistics. Only to understand the population characteristics, we look at statistics. And these statistics are calculated from a small portion of the population. What we call it as sample. Isn't it? We pick up certain units and this is nothing but the sample. And with the help of the sample, sometimes it is just 10 pieces, sometimes it is 100 pieces, sometimes it is 30 pieces, right? But whatever is the number, and with appropriate sampling technique and the appropriate sufficient sample size, if you calculate statistics, you will be able to judge on the characteristics of the population. I mean, judge in the sense you will be able to find a value which is too close to the population characteristics. And through the sample characteristics, we try to understand the population characteristics. That way, this is also inferential statistics. Through the known, we are trying to find out the unknown. That is also inferential statistics. So ultimately, your decision making depends on your statistics, and your statistics depends on your quality of the data as well as the quantity of the data, isn't it? So that's why we have a separate phase known as measure phase. Our job is now only to collect data and calculate some statistics and try to understand what's happening. You call it baseline, and try to understand what's happening in our process. I mean, what's happening in my workplace. So this is called baseline performance. So please give enough care while collecting the data. Garbage in, garbage out. So you might think that your baseline is a specific value, but the reality may be completely different. And then the whole project will start moving in a wrong direction, isn't it? So Six Sigma projects are data-driven projects. So we have to be extremely careful while collecting the data. And that is why we are going to talk to you about various tools related to data type, and the operational definition. And then we have sampling technique. There are different sampling techniques available. But ultimately, even after completing the measure phase, we are not going to give you any ready-made solution on how to collect the data, because you are going to come out with the data collection plan. We'll teach you by putting a slide, a data collection plan. It doesn't mean that you can follow the same thing. No. Your problem and my problem and others' problem are different problem. So never the solution will be same. So data collection plan has to be evolved by you, but you can definitely gather a strong foundation using which you can come out with a good data collection plan, isn't it? Let's say you want to understand about the performance of a company, then performance of a particular process. And now when should I collect data? Should I collect data in the first shift, or should I collect data in the second shift, or should I collect data from the third shift, or should I collect data from all the three shifts? Who
All
can
the
answer
three
this
shifts.
question? You
All-
can answer
all
the
three.
question better. All three shifts. Because you are now, you don't know, you are not very clear from which particular shift that more defects are coming. That question is itself is not known. So you should obviously collect data from all the three shifts. Suppose if you have some specific understanding that the rejection is more in the night shift only, and your project is scoped only to study or control the rejection rate in the night shift. Now, where from your data should come? Only
Night shift.
night shift, because
Night
your
shift.
project scope is now limited. So that is why scoping is very, very important. The broader the scope, the effort required will be very high. So that's why in the define phase, you have to take all measures to ensure you address a specific problem with the scope narrowed to the extent possible, so that when you work on define phase, measure phase, analyze phase, improve and control phase, you will be able to take decisions easily. Otherwise, you will definitely get struck while making decision. Which sampling technique I should use? I don't know. You will simply ask someone and they will also don't know. You refer some book and it will definitely be not written in the book. Your situation is known only to you. And that's why, the define phase is very, very important. So with that note, I'm going to teach you some basics behind statistics. When we say statistics, very, very important concept is normal distribution. So that has to be thoroughly mastered. Why? Because by following a specific data collection method, you can definitely make your data follow normality. If you can make your data follow a specific pattern, then understanding the behavior of the process and then improving the behavior of the process and confirming the behavior with the data, all of this will become easier later on. All right. So if you know how your data will behave normally, then you can start expecting the same in the future, because this is how my data will behave. Say, for example, we all know how our children will behave, isn't it? Different situation. If he scores a less mark, how he will behave. If he score more mark, how he will behave. Right? If you take him, out for a purchase, how he will behave. So you have a idea. So suppose on a particular day, if the behavior is completely different, then you will be surprised to see how it is. He normally behave in this manner, but now the pattern is different. So you will start suspecting. So something should have happened in between. That is your doubt, isn't it? The same manner, you should be able to ask question yourself, right? How come this data come from a process? If this data come from a process, definitely my process is affected by something which is not known to me. Am I right? Right? So ultimately, we are trying to study the variation. And throughout the course, we are trying to understand whether the variation is due to common cause or special cause. Ultimately, we are trying to understand whether the variation is due to common cause or special cause. Common cause, we use another term, random cause, which means we can't tell any reason. It happens randomly. For example, all the particles, the molecules in the air, will they be vibrating? Yes or no? All the molecules in the air, they always vibrating a little. Am I correct? They are not
Yes.
static.
Correct.
But but we can't control everything. Even if you control the environment to a great extent, still there will be a small, what you call the vibration at at a particular frequency, they'll be vibrating. Their amplitude will be some value. So you can't control beyond certain level. So that means whatever leftover is the variation due to random cause. While designing your process, you normally leave that random cause variation. Isn't it? Random cause variation. But then if something seriously goes wrong, the variation will start shooting up. The variation will start increasing. As the variation increases, then you will realize something external to the process is now playing. Am I right? At the time you designed the process, you designed all your factors in a particular manner, and according to that, only a minor variation is possible. But all of a sudden, if somebody uses the wrong cutting tool, now what happened? The variation will increase. So this is what basically we want to understand. Whether the variation is due to random chance or variation is due to special cause. Random cause, special cause. We sometimes call it common cause, special cause. Sometimes we call it unassignable cause, assignable cause. Unassignable cause means a reason cannot be found. Assignable cause means reason can be found. So this is the question we are trying to understand. For this purpose only, we collect data. The moment we understand that the reason for the variation is random, we can't do anything. We will simply ignore. We will simply ignore. Sometimes even after collecting data, we don't take any action. Because our understanding is the variation found is due to random cause. But sometimes after collecting data, we'll be very sure the variation is not due to random cause. The variation is due to a special cause. And this is what we call it, the root cause. What is that actually, influenced the process so that, the variation is high. And that root cause we will try to fix. So for that matter, we are going to learn some statistics, and this statistics will also help you to calculate the baseline performance also. So this particular session is going to be very, very important because you are going to find the answer for this particular question. What is exactly Six Sigma? We have been, thinking about this question right from the beginning of the course. When I say 3 Sigma, what does it mean? When I say 6 Sigma, what does it mean? When I say 2 Sigma, what does it mean? And they're all connected to the other measures of baseline performance, like DPMO, CPCPK. So we are going to connect everything. So in order to understand the Sigma level, we should know some statistics, at least mean and standard deviation. Mean is a measure of central tendency. Standard deviation is a measure of variation. Similarly, we should have idea about specification limit. Normally, customer will give specification limit. Any product you buy, you give the specification limit. Similarly, your customer will give specification limit. And then control limit, a concept of control limit, we derive from normal distribution. And if you know these 4 things, yes, Sigma level can be calculated. And that is what we are going to understand with a very, very simple example.
So one question, sir.
Yeah, please.
Here we are talking of the different statistical methods, but here we are only talking more about the deviations in the quality. So can this methodology be also used other than quality?
Why not? See, quality will reflect in your quality data.
Yeah.
Productivity will reflect in your productivity data.
Productivity data. Yeah.
Cost will reflect in your cost data. Right? So it can be used. Suppose you want to improve your delivery time, then you start collecting the data about delivery time. You define the delivery time, collect the data. Normally, delivery time will be within a particular range.
Right.
All of a sudden, you started seeing the deliveries happening outside the normal range. And similarly, with doctors, they collect your body parameters because they understand your health through the body parameters. If your body parameters within the normal range, it is random cause. They don't take it very seriously. Okay, no problem. Don't worry. It will be like this. For any man, any common man, the variation will be like this. But at times, if they see your body parameter outside the normal range, they will advise you to get admitted in the hospital. In this condition, don't go out. You have to be admitted immediately. Why? Because they know it is special cause. All right. So
Okay.
it can be used in any situation for any. So Six Sigma is a domain neutral concept. You can use it. You understand the principle, you understand the science behind, and then you apply it in your field.
Okay.
So specification limit, control limit, stats for Six Sigma and 3 Sigma versus 6 Sigma, and then Sigma and Sigma level, and benefits to the organization as well as to the individual. This is what we are going to understand.
Sir, this is Naveen here. One quick question, sir. In the previous understanding, I was always given to understand that when we are doing this, the level of certification, or maybe you can correct me if I'm wrong. So generally for common cause only, we will be doing this higher level of analysis, like black belt or something. Is that true?
No, for common cause, the ultimate definition of common cause is you can't control it.
Right.
You can't control it. But special cause, yes, you can take action. So we don't do any analysis for common cause. We do analysis only for special cause.
Okay, sir. Thanks.
All right. So now we want to design a process. Imagine we want to design a process. How do we normally want to design a process? Do we want to design a process in a way that it becomes challenging for us to get the result? Or do we want to design the process in a way that it is very, very easy to manage? What is our expectation?
Easy to manage. Easy to manage.
So let me show you some process here. I'm going to play a video. Just a second. I'm passing the. Tell me, is this process designed in a way it is challenging for the elephant, or is it designed
Yes.
in a way that it is difficult to manage?
Difficult to manage.
Challenging.
What is the difficulty here?
He has to step inside the
Sliding into the
swimming
tub
pool.
itself is difficult, and accommodating him itself is difficult.
Accommodating the elephant inside the tub is difficult.
Difficult.
The
Okay.
size of the elephant and size of the tub are more or less equal. Similarly, when you design a process, accommodating your process within the specification given by the customer has to be understood. You should be comfortably accommodate the process inside the specification rate. Am I right? If you
Yes.
keep your process very wider, then accommodating it will become very tougher, and your process will also struggle like the elephant you have seen now. So now let me show one more example. And there you see what it.
Yes.
So how we made it easily manageable one? We increased the size of the tub, isn't it?
Yeah.
Here, increasing the size of the tub is possible. But now in any business, in any process, we will be playing between the specification or the customer tolerance and the process tolerance. Customer will always give some specification. That is what is known as tolerance, isn't it? That is called customer tolerance. And your process will always have variation. That is called process tolerance. Now tell me, which one you can control now? Here you controlled the tub size, not the elephant. Similarly, in business, will you be able to control the customer tolerance or the process tolerance?
Process tolerance.
Process tolerance.
So try to ensure the process operate with less variation, so that the process extreme limits will come inside the specification limit, making your process easily manageable. Right? And that is the idea. So you now know, if you keep your process bigger, or the process size bigger than the customer provided tolerance, then definitely your business has to struggle. But if you design a process in a way that your process can operate completely inside the spec, then your business will definitely deliver excellent results. Particularly the product qualities will be very, very high. I mean, all the units that comes out will be acceptable. So similar understanding you can have here also. See here, there is a parking space, and then there are 3 different cars. Parking space is fixed. you can't change because it is already constructed. Now you have option to use the car. You can use a bigger car, or you can use a car which is equal to the size of the parking area, or you can use a car which is smaller than the parking area. Which one will you use now?
Third one.
Third one.
Third
Because
one.
you know you
Third one.
will repeatedly use the car, and you will not be in the same mood every time you are parking the car, isn't it? So in order to avoid failures, in order to avoid the damages that
Damages of the car.
that may be caused to the car, now you carefully chosen this car. The same way only you should choose the process also. Always prefer a process that has less variation, right? The first car, if you take, now what are the control limits for the car? Control limits are nothing but the points, or we can say the extreme point. If you take care of the extreme point, then everything inside will be safe. For example, when you are driving a car, if you ensure the side mirror is not touching the wall, it simply means the entire car is safe, isn't it?
Correct.
You are driving straight and the side mirror is not touching the wall. It means, the entire car is safe. Similarly, on the left side, this is what is known as control limit. The extreme point that can come out of your process, and you ensure your control limits are safe. It simply means everything else is also safe, right? So control limits here are seen outside the specification limit. Your car has to be damaged. Your car has to be damaged. If you see the control limit outside the specification limit, there has to be rejections. You have to live with the rejections. All of you understand? The second type, control limit touches the specification limit. The car side mirror just touches the wall. It looks as if, the car is going smoothly, but even a small variation, isn't it? A small source of variation can easily bring big problem. Am I right? If you can,
Yes.
the designing of the process is in your hand. You can design it the way you want. You think, this is okay. You are focusing on short term. You're not focusing on long term. Isn't it? Today it looks the car is going in, but if you have to do the same thing again and again, and the damages will be more. So this is also not a preferred scenario, but this is definitely a preferred scenario, right? You are parking your car, same time your boss is calling you and you have to attend the call. So you lifted it, but even then, you are able to park your car safely, which is not the case in other situations, isn't it? So that means our process is made extra capable. This is enough, but this is better, right? And this is enough only for short term, but not for long term. But here, our car is safe even today, even considering any future scenario. The boss can make a call while parking, your girlfriend can make a call while parking, and your wife can make a call while parking, and you will definitely handle all of this, no? And that's the capability. That's called the capability. Hope it is clear so far.
Yes.
So what do we learn so far?
That
Process
control
specification and customer
Process.
specification.
control tolerance.
Customer specification.
Process specification, customer specification. Customer specifications are known as USL and LSL.
LSL.
Process specifications are known as UCL and LCL.
LCL.
And our goal is to see the UCL, LCL inside USL, LSL, so that all our products are safe. No rejection will happen. The chances of rejections are very, very less. And now similar example, you're seeing a runway, aircraft runway, and you're also seeing a Boeing waiting for you on the right side. And now you imagine you are flying this aircraft several thousand meters above the ground, and you have to land the aircraft because someone is testing how good you are in landing the aircraft. So the process is landing, and you are asked to make 100 landings. Now tell me, if you have to make 100 landings, one after the other, at some, the same process you are repeating. Now tell me, in the runway, where will you try to land your aircraft? You can see the runway, right? With a lot of markings.
Yeah.
There's a marking exactly at the center. There is a marking at the end of the road.
Yeah.
Which marking you will choose for your landing?
Center.
Always in
Center
between
one.
those two lines, center.
Always.
Exactly on the center. Yeah.
Because the center is the safest point. The risk is minimum. The risk is minimum. Because what is risk here? When I don't land on the runway, if I land outside, then that will be a danger. It can lead to some crashing of the plane, isn't it? So
Yes.
I don't want to cross this line. I also don't want to cross this line. So the safest point is center. Similarly, in any business, you need to understand what are your boundaries. I mean, customer limit, specification limit. Always the center point of the customer specification limit is the safest point. That should be considered the target. That should be considered the target. So now, can you see your landing points around the center line of the runway?
Yes.
Why the pilot is, why all the landing points are only around the center line? Why not, why it has not come to this line? Why it has not come to this line? Any guess?
The wheel is at the center.
Yeah, because as a pilot, you wanted to land in the center. So your intention is reflecting in the data. Your intention is to land at the center. So your data also falls there. Similarly, the intention of the process can also be understood by looking at the data. You design the process, then process will tend to produce something. What is the tendency? Is it the tendency itself is on the target, or is it the tendency is away from the target? If the tendency of the process itself is away from the target, this is what is known as process shift. This is what is known as process shift. Always you should design a process in a way that the tendency of the process to produce output should be on the target only. All right. So now one more landing. And this time, what is your comment about the landing? Is that the landing is okay?
Yes.
No, it is out of the, of
Not
course,
okay.
Looks to be far away from the target,
target.
but still inside the specification.
limit.
I mean, still inside the runway only. It is safe for the passenger, but still you understand the pilot is not that much good this time. Isn't it? This is how you should also comment when you look at any process, right? Don't be happy about just seeing your product inside the spec. Try to get your products closer to the target. This is Taguchi's philosophy of quality. Variation is a loss. The loss is more here. The loss is less here. Can you see that? Quality loss.
Yes.
Quality loss is less here, but quality loss is more here. And here it is extremely more. And here there is no quality. Now few more landing points. Okay, right? And few more landing points. And few more landing points. Now 100 landings. When you have sufficient amount of data, if any process is run naturally, and you will see a kind of pattern appearing in your data. And can you see a bell pattern? Right? You can see a bell pattern. And now look at the bell pattern. Majority of the data points. Majority of the data points. Where are you seeing in the bell? Are you seeing in the extreme or in the center?
Center.
It is center.
This is one important property of normal distribution. Majority of the events will happen around the center. And approximately it is 68%. Approximately it is, there is 68% chance for the pilot to land the aircraft in the center of the runway. All of you understand? All of you are with me?
Yeah.
Sir.
Now, similarly, this point is the extreme landing. You can see that. As far as this process is concerned, your control limit should be somewhere here. Am I right?
Yeah.
Because when I say control limit, if the pilot is landing again, making another 100 landing points, again all 100 will definitely fall inside this point. That is the idea, right? So this point is nothing but the target, and when you have data, please calculate a statistics called average. And our goal is to get the average right on the target. Our goal
One
is,
question, sir.
yes.
In this bell shape, the deviation towards the bottom, it is still acceptable or it should not happen? Yeah, specifically that area.
Yeah, very good. So the deviation you can see only in the bottom of the curve. This is
Right.
called exactly deviation. There is a deviation on the right side. There is a deviation on the left side.
Right.
This is called process spread, also known as variation. If you control this variation, it is as good as trying to get everything around the targeted value, isn't it? If I control the variation, it simply means I am trying to get everything on the target, isn't it?
Right.
So, but always, see, we will be always trying our efforts to reduce the variation. We'll be always trying our efforts to reduce the variation. But if the complete spread, if they are seen inside the specification, see here, the range, this is the range given by the customer. But your process range is smaller. So that means you are running a healthier process, you are running a capable process. But if you can reduce the variation further, it is always better. The moment you understand there is a scope to reduce the variation further, you please reduce, right? And we can't say, yes, this much variation is okay. No, it
Okay.
depends on your process and product. When you are selling sugar, for 1 kg sugar, you don't mind giving 1 kg and extra 10 grams, isn't it?
Right.
The 10 gram variation is tolerable. No, that's not a matter when you are selling sugar. But when you are selling gold, you can't give 10 grams extra
Right.
while selling 1 kg of gold. The amount, the variation is same, but still it is not acceptable with the gold, but it is readily acceptable with sugar. So what I'm trying to say is the variation depends on the process you are controlling, right? So this is target and this is process average. And for a process which is properly centered, a process which is having a tendency to produce the targeted value, in those process, the statistics called average will appear exactly on the target. All of you understand? Hereafter, when you calculate average, make sure you get your average on the target. When you get your average on the target, it doesn't mean everything is on the target. But it definitely means the tendency of the process to produce products on the targeted value is high. Am I right, all of you? Yes.
And it is the average towards the in the bell shape, the average of the deviation at the bottom, or all the deviation. What
Average
exactly?
of all the values.
All the values.
Every point here is a data.
Okay.
You
Okay.
sum up all the data and divide by the number of data, and that will give you average.
Understood.
Nothing but the center of the spread.
Okay.
Now this is considered as control limit for the process. Which means you are able to see almost all the points inside the control limit. This is control limit on the left side.
Yeah.
And here the runway ends. That is specification limit, upper spec. This is lower spec. So customer target, upper specification limit, lower specification limit, upper control limit, lower control limit. And now tell me, is that the pilot flying the aircraft in a proper manner, or do you see any problem with the pilot's flying capability? I mean landing capability.
No, I think it seems to be in control.
Very good. The landing capability is really good. We can definitely fly with this pilot. He is never going to put us in trouble. Almost all times, he is able to land the aircraft in the runway. All the passengers are always safe. Can you see that, all of you?
Yes.
That means if you produce 100 products from your process, all 100 products will be accepted by your customer. If you produce 1,000, 10,000, all 1,000, 10,000 will also be accepted. But when I make it 1 million or when I make it 10 million, little doubt happens, isn't it? So if you want to reduce that doubt of failure, you need to work on the spread. You need to work on the spread. So the lower the spread, lesser will be the rejection, even if you are trying to produce some bulk quantity. Do you understand? Lesser the variation, still you can expect nil rejection, even if you are trying to produce quantities in large numbers. All of you understand? So if you want to produce 100 units, I think this process can be run as it is conditioned, because the requirement is only 100, isn't it? But if the requirement is 10,000, 10 million, then probably you might think of reducing the variation further. Hope all of you understand. So now this process is capable. The whole game of any business or decision making is comparing the control limit or position of the control limit with respect to the specification limit. Right? If you can see your control limit inside the specification limit, immediately you can conclude your process is capable. That means the risk of failure is minimum. Hope it is understood by all of you. So certain things we have learned here. Customer will always give a target. We must understand. And our statistics, particularly average, known as process average, should lie on the target. Am I correct?
Okay.
If the average we calculate is deviating from the target, you can understand something, the tendency itself is wrong. If the process tendency itself is wrong, then the process cannot give good result. The intention has to be good always, isn't it? Right? So that's what we are checking. And another thing, the deviation, also known as variation, is possible in all process. It's a natural phenomena. You can't say, there is a process with the zero variation. No. Variation is a natural phenomena. It will be there. We must admit it. But the thing is, it should be minimal. And we always strive to reduce the variation. And then customer limits are always provided by the customer himself, right? And if he is an external customer, and these are upper specification limit and lower specification limit, and if you produce anything outside of this, then it is known as external failure. Now, new way of defining external failure. In the day one, I taught you external failure, internal failure. What was the understanding that time? If the failure happens outside the organization, it is external failure. Now I am defining in a different manner. If the failure happens, or if you produce a product outside the specification, then it is external failure. And so what is the definition of internal failure? Any process will obviously have process limits. If any output is produced outside the control limit, please listen to me very carefully. I'm not saying the product is outside the specification limit. It may be still inside the spec, but I am seeing a product outside the control limit. That also will be considered a failure now. Your customer may still be, ready to accept your product, ready to buy your product, but still you as a Six Sigma expert, you don't want to sell it. Can one of you answer why? The product is outside the control limit, but still it is well inside the specification. But even then, you don't want to sell this product. Is there a reason behind this?
Yes, sir. There is always a possibility of that variation goes beyond UCL LLC and prone to get rejected. So there is a possibility of producer's risk.
Yeah. If I sell such a product, it can quickly deteriorate and quickly go out of spec. So I might have given a 1 year warranty, but my product will fail within 6 months. Everything I have sold in the last year, now I have to replace, because almost all the products are failing within 6 months. I have to actually pay for the warranty claims. So this is known as internal failure. This is Taguchi's philosophy of quality. Only those who can understand Taguchi's philosophy of quality, you can talk about warranty. Am I correct?
Correct.
All right. So now I'm taking you through another game, and you all might have played this game while spending time in the beach, isn't it? Shooting the balloons. They'll give you a gun, and the game is let me define the game. You need to hit this balloon in the center. What is the color of the balloon in the center?
Red.
Red color. So that is the target. Now I give you a gun, a lengthy barrel. Now tell me, how will you shoot this balloon? I give you 10 bullets, and all 10 bullets you are expected to hit here. If you hit the first balloon, then it will be replaced. And again, you have to hit the same thing. Do you understand the task?
Yeah.
Yes.
Now, one of you, can you explain how you will, shoot the target? What kind of, measures you will take to ensure you hit this balloon repeatedly at the target? Yeah. One of you can tell me what needs to be done so that we can hit all 10 times the red balloon.
Should target the barrel on the red balloon.
Target the barrel on the red balloon. That means, I think we must definitely clap for this answer. That means Vineet is suggesting, sir, hold the gun correctly, isn't it?
Yeah.
Pointing the gun onto the sky and expecting to hit the target is not going to happen. That is his point. This is what we are also learning here. The process average should be on the target. It means you are pointing the gun on the target. That's the starting point. All of you understand how important it is to get the average on the target. If your average itself is off-centered, it simply means you don't even know how to hold the gun. You can never be a professional shooter, isn't it? So the first point is agreed. Can you see the gun now pointing the target?
Yes.
This is statistically average on the target. Average on the center point of the specification limit. And now you need to control yourself, isn't it? So that you are not shaking the gun or you are not changing any settings. And repeatedly you have to release the bullet. The first bullet hits, right? The second bullet also hits. Can you see an highest level of consistency in execution here?
Yes.
Now variation is 0.
0.
Which is against nature. But in business, some variation will happen. So your balloons sometimes, instead of hitting the center balloon, may hit the first round. Anyone in the first round, isn't it?
Right.
And if the variation further increases, the bullet might start hitting the balloons in the second round.
Yes.
If the variation further increases, the bullet might start hit balloons in the third round. So this is the problem with variation. If you allow the variation to increase, slowly, your process will tend to produce products away from the target. Here the quality is little bad, but still okay. Your customer can't see it, isn't it? And these products looks okay, and this looks far away from the center, isn't it? Suppose if you ask someone to shoot the target, shoot the balloon, and if he completely misses all the 3, that means instead of shooting the balloon, he is trying to shoot all the audience who are sitting in the right. So that means can you see an unprofessionalism in the shooting, isn't it? He is supposed to shoot this particular balloons, but then he is actually trying to shoot the audience. And this is the exact meaning whenever your process produces output beyond control limit. All of you, can you see that?
Yes, sir.
Yes.
If someone is if a process is producing products outside the control limit, it is as good as trying to shoot the audience instead of shooting the targets. So it is definitely an unprofessional attempt by your process. That is why we don't have to wait till our product or output goes outside the spec. The moment you see something outside the control limit, you can immediately stop that fellow, isn't it? Otherwise, a lot of people will lose their life. All of you understand why we become serious when we see an observation outside control limit?
Yes, sir. It is total loss to organization.
Yeah, that means that particular shooter is definitely unreliable. If you don't stop him immediately, you know what will happen? The next bullet will point to your head. Yes or no?
Yes, sir.
So that's why control limit always lets you understand whether the products are staying inside the control limit or going outside the control limit. Even if one person in the gallery, if he dies, then immediately, the shooter will be stopped. Am I right?
Yes, yes.
Same manner, if your organization has a control chart, if you see one point coming outside the control limit, will you take action? Or will you just, still keep yourself calm? Only 1% died. There are thousands of people there in the gallery. Let few more die. We never think in that manner, isn't it?
Right.
Same manner, when you see just one point coming out of the control limit, you are expected to take some action. So this is new way of defining quality. Now the new definition of quality according to Takuchi is quality is statistically a function of average and variation. Quality is a function of central tendency and variation. Or quality is a function of average and sigma, which is standard deviation. What is our requirement here? Average should be on the target. What is our requirement on the sigma? That which is variation. You want less variation or you want more variation?
Less variation.
Less variation.
So less variation with the central tendency on the target equal to best in class quality, world class quality. That's all. So hold the gun correctly and hit the target consistently. So normal distribution. And can you see the bell curve one more time? All of you can see the bell curve, right?
Yeah.
So here,
Yes. Low battery, please charge.
in a bell curve, the statistics, mean, median, and mode, all are measures of central tendency. Mean, median, and mode, all are measures of central tendency. If your data is perfectly normal, mean, mode, and median all will be equal. For example, let me give you a data. 1, 2, 3, 3 times. 1, 2, and then 3, 3 times. And then 4, 5. How many data is there in my series now? 1, 2, and then 3 times 3, 4, 5. Totally how many data?
Low battery, please charge.
Totally how many data?
7.
7. Now what is the mean in this case?
Middle of the point is mean.
Mean
Or
will be
average.
mean will be average, which is 3.
Average.
If you check, it will be 3. What is median? There are 7 points. Which is the center point? 4th point is the center. That is also 3. Which points occurred repeatedly? 3 occurred 3 times.
3.
So mean equal to 3, median equal to 3, mode equal to 3. This will be the situation if you see your data in a perfect normal condition. Clear? So one important property of perfect normal condition. Now another thing, the curve is symmetric at the center, which means when I draw a line at the center, it will divide the curve into exactly 2 halves.
Low battery, please charge.
Suppose you have a land in a perfect bell-shaped land you have got, and you are dividing the land by constructing a wall here. Now the total land area is 1 acre. Now the right side of the wall will have half acre, left side will have half acre. Because it is a perfect normal, so the curve is symmetric at the center. All of you can see that?
Yes.
The total area 50%, and so when I draw a center line, the right side area will be 50%, left side %. Okay. Now that 50% is also divided now. You can see that by constructing walls at equal distance from the center. Equal distance from the center here, equal distance from the center here, and equal distance from the center here. The entire area is now see here, this point till the point your land is ending. That portion is divided into 3 parts. Can you see that, all of you? Suppose from here to your land ending, let me say it is equal to 90 meters. How much is the distance? 90 meters. Now what will be this distance? 30
3
meters.
parts the 30. Yeah.
This is another 30 meter. This is another 30 meter. Now I construct a wall here, construct a wall here, construct a wall here. Now the 50% will get divided in this manner. 50% will get divided in this manner. You must try to remember these numbers because this is going to help you make decision. So same manner in the left side. Now you will be able to see the first wall from the center on the right and the left will include 68% of your land area. All right.
Yeah.
The second wall from the center on the right, the second wall from the center on the left, that will include 95% of your land area. When I
Yeah.
go to third, almost my entire land is covered. Right? And beyond that wall, nothing is available. That's the meaning. But still, statistically, a small portion is left out. Right? So that means where the blue area is 68.27, brown area is 95.45, blue, brown, and green area is 99.73. So here, the center is mean. And the first wall is constructed at 1 standard deviation. In any data, in any process that is operating normally, the center will divide your data into exactly 2 halves. For example, here we have sufficient number of participants. Maybe all of you can do this exercise, but for the interest of time, I'm not going to do it, but I will only orally explain. If I collect all your age, will there be an average age?
Yes.
All
Yes.
your age. Age is also a biological data. Right? So your age, what could be an average age? Can you tell me roughly? Can you make a guess?
40.
40. So that means 50% of your participants here are having the age above 40. Is that true? Can you please raise your hand? You have the reaction. Let me see. Let us see whether it is working, the normal distribution. So, no, you have to show the press the reaction button. Maybe people are not familiar with the reaction button, isn't it? So, unless and until all of you, you reveal the fact, it is difficult to verify. Okay. Okay. Okay, we'll make an assumption here. All right. So approximately 50% of the participants are above the age of 40. And so remaining 50% of the participants are below 40. That is the logic here. Now, if I have really all your age data, the statistics average will definitely appear towards 40. That's the point. And now if I calculate standard deviation, what do you think could be the standard deviation here? What is the maximum aged participant and who is the youngest participant here? I don't think that we are trying to find out the old man here. No, we are not trying to find out the young man here. We are only trying to understand normal distribution. And who is youngest here? Youngest participant. We will not ask for the old man here. Because left side and right side, right? We will use the left side. Who is youngest here? Can you please tell me your age? 31. Pawan Kumar says 31. Okay. We consider Pawan Kumar as the youngest participant. So the average is 40 and the lowest is 31. How much is the difference? 31 and 40, how much is the difference?
9.
9. Now divide that distance by 3. 9 by 3 is how much?
3.
So standard deviation is 3. Now, I am going to make a statement. 68% of the participant are in the age group of 37 and 43. If all of you can participate, maybe if all of you come on video and try to show the reaction, we can verify straight away. Right? 68% of the participants will be between the age group of 37 and 43. Logical?
Yes.
This,
Yes.
but all you have to participate then.
Yes.
That we do. All of you, do you know how to press the reaction button? Or if you don't know, please come on video. Let us see. Let us see. Right? So those who are falling in this range of 37 and 43, you have to press the reaction button. We need to check. But if you don't participate, we will be biased and all these principles will not work. and you keep on pressing the reaction button, otherwise it will vanish. I don't think normality is working here. We need to have more people, more participant then. We need to have more participant and then more participating participant. That is also important, right? I think probably with the data, we'll get a precise measure of standard deviation and we'll get this working very closely. So 68% of the participants are in the age group of 37 and 43. Now I can increase the age group 33 and 46. Now I should also, lift my thumb, isn't it? So let me do that. So what is the age now? 33 and 46.
46.
Now all of those who come in this range, now when we raise the thumb, we will be able to see almost 95% of us coming in this category. Am I right?
Yes.
Now the third range. What will be the third range? 31 and 40. Or 31 and maybe 49, right? 31 and 49. And between 31 and 49, I think all of us will now be raising the thumb. Am I correct?
Right, right.
That is why it is written as 99.73. But still in the same group of participants, there can be one or two who may have an age higher than 49. They are known as outliers. They are known as outliers. Similarly, there can be, if there is a participant having an age less than 31, then he is also outlier. That means what do you understand with this exercise? Normally in a Six Sigma training program, people in the age group of 31 and 49 are expected as participants. Am I right? If tomorrow you also want to conduct a Six Sigma program, please target your campaigns in this age group. That will work best. People below 31, they don't have that awareness. People above 49, normally they might have lost the interest to study further, isn't it? So that is what the normal distribution is conveying. So this is, you can use this understanding to decide better. If you want to run a digital marketing campaign and you at the same time you wanted to have a focused target audience. Now which group, which range you will choose? I think you can target the blue color region, isn't it? The blue color region, a lot of people are there. If you run a campaign targeting people in the age group of 37 and 43, your campaign conversion rate will be higher. Right? Because more people are joining the program. That's what we could see. So this is how you can use. If you are producing a product and you're expecting something, some characteristics in your product, it can be surface finish or it can be strength or it can be some kind of number. And what percentage of your product you want to see inside 1 sigma limit? What percentage of products you want to see inside 2 sigma limit, 3 sigma limit, and you will be able to judge better. You will be able to decide. So exactly half of the value will appear to the left of the center and half of the value to the right of the center. Anyway, the total area under the curve is 1 because the total area is 1 acre. Total percentage of the total area, if we express in terms of any unit, it is 1. In terms of percentage, it is 100%. In terms of probability, 0.5 on the right side, 0.5 on the left side. Right? If I choose a person randomly, what is the probability for the person to have the age above 40? Can somebody answer this question? I choose randomly 1%. What is the chance for the person to have an age above 40? 50% chance, isn't it?
Yeah.
Because we
Yes.
have, more than 40, 50% people, more than 40, 50% people. So the probability for a person to have an age above 40 is 50%. That is the right side area. Probability for a person to have an age below 50%, 40 is another 50%. Now see here, suppose if I ask you, what is the area between the 1 sigma line on the right side and 2 sigma line on the right side? Will you be able to answer this question? What is the area between the 1 sigma line on the right side and 2 sigma line on the right side? What is the area?
13%.
13.6%.
6%.
Now imagine you are producing a product surface finish, right? The surface finish required is 100 micron, right? Be it logical or not, I'm just assuming 100 micron. And customers, you collected some data about surface finish. The average is 100 microns. Standard deviation is 3 micron. All of you are with me?
Yeah.
Average is 100 micron. Standard deviation is 3 micron. Now tell me, what percentage of your product will have a surface finish between 103 microns and 106 microns? How many of you understand my question? Your average surface finish is 100 micron. Where is 100? Here, right?
Yeah.
Average is the
The
center.
center, at the
So
center.
100 micron is here. And
Center.
standard deviation is how much?
3 microns.
3 micron. So you are referring to this line, 1 sigma line, 103.
Yeah.
And what is this line? 2 sigma. 2 sigma means what is the value here?
6 micron.
106.
Yeah.
106 micron here, 103 micron here. Now I am asking you what percentage of your products will have a surface finish between 103 micron and 106 micron?
13.6%.
100.6.
Beautiful inference, isn't it?
Correct.
Your operators are producing product and you have collected data. Now you understand 13.6% of the products are having the surface finish between 103 micron and 106 micron. And if you feel happy about it, okay, continue the process. Otherwise, you have to reduce the variation.
Correct.
Isn't it? You can reduce the variation. So the average surface finish is 100 microns. If that is again acceptable, you should be happy about it. If that is unacceptable, you must try to shift your process. So this is the kind of inference you can make when you have data. All of you are with me so far?
Sir,
But
sir,
ideally-
how did you get that 103 microns and 106 microns? I didn't get that part.
103 is, I calculate standard deviation out of the data. 100 micron, you know how to get it? That is average, right? For average, there is a procedure. You add the number and divide. Similarly, for standard deviation also, there is a procedure we will be learning now. And all of you have already learned it in 7th standard. And one more time, we are going to learn again now. So standard deviation is 3.
Yeah.
So once you know standard deviation, then this is 103, then this is 106. And this will be, for how much this will be? 109.
9.
So 1 standard deviation away from the center, 2 standard deviation away from the center, 3 standard deviation away from the center. Normally 3 standard deviation away from the center, that point is known as control limit. Because normally we have very, very less chance of getting points beyond control limit. Can you see that?
Yeah.
It is as good as 0. So this point is known as control limit. And the 2 sigma point, that is known as warning limit. This is simply known as 1 sigma limit.
Yeah.
All right. So now you understood normal distribution. All of you, are you clear with normal distribution?
Yeah.
What will be the shape of normal distribution curve?
Bell shape. Bell shape.
Bell shape.
Bell curve.
Bell shape,
And bell
Bell.
curve, what are the properties of bell curve?
mean, median, mode.
Median mode.
Mean equal to, median equal to mode. Equal.
Mode.
For-
All will be
Only for
equal.
normal distribution.
Okay, only in perfect normal distribution. Then, what are the other property you learned?
Symmetrical.
Symmetrical at the
Symmetrical.
center.
Symmetrical on either
Center.
side.
Can you
Center.
give the same statement in different language? I mean, in different manner. Symmetrical at the center means half of the points are on the right side of the center, half of the points are on the left side of the center.
Yes.
Approximately 50% of the curve is to the right of the center. Approximately 50% of the curve is to the left of the center.
Absolutely.
0.5.
The probability for any point to appear to the right of the center is 50%. Can you say all are
0.5.
correct, right?
Yes.
Yes.
What is the probability for a point to appear to the left of the center? That is also 50%.
50%.
I can say point, I can say event, I can say even products. It all depends on the kind of data I'm using. In the runway example, they are landing points. What is the probability of the pilot landing the runway on the landing the aircraft to the right side of the center line? 50%. Right? So likewise, you can also take decisions in your business. And now again, there is a small story here. See, a lot of people are living in the village and they have to cross the river every day. They don't have any kind of boat or something to cross. They have to walk through the river. And now they have to judge the river. Then only they can safely cross the river, isn't it? And
Yeah.
here the important characteristics they need to judge is the depth of the river. Am I right?
Correct.
Right.
The color of the river and all those things really doesn't matter. They are not CTQs. The real CTQ now, critical to quality, is critical to life, I would say here, because they are crossing the river, is the depth of the river. And now imagine you are the group leader, and now you have to make a judgment how depth the river will be. Now what will you do? There is no other option. Somehow you have to measure the depth, isn't it? Now the river is almost 1 kilometer in the, what do you call, the width of the river is 1 kilometer. So you probably have to test the depth of the river, the depth of the river across the particular route. Am I right?
Yes.
So now tell me, there are 3 routes you are choosing in your mind, you are planning. Let us try to cross the river in this manner. This is one option. Another option is the shortest route. See, please understand, the shortest route need not be the safest route. Am I right?
Correct.
Yes.
It is shortest and it is little longer, and this is too longer. But now you have to take a decision. Which route can be safer for your people? And now, if I get you some information about the depth of the river along route A, route B, and C, that will be really helpful to you. Am I right?
Right.
So I am telling you, I will get you the data, but I'll get you only minimum, not too much. Maybe 5-6 data point here, 5-6 data point for route B, and 5-6 data point for route C. I'll also charge you some money. And now you also agreed. Yes, sir, that will be helpful. Now tell me, how will you advise me to collect the data? I am telling you that I will give only maximum 5 to 7 data point in every route. Now tell me, what will be your data collection strategy?
Different height, different depth
Depth.
along the route.
Different depth. That means you will expect me to collect more data from the center of the river. Am I right?
Yes.
That is what you studied in normal distribution also. 68% of the data points will be around the center. Isn't it? So you will also have a same strategy. Sir, please get me 68%. If you are collecting 10 data points, at least 6 data points should come from the center. Good strategy, data collection.
Yeah.
Then remaining 40% can be outside the center region of the river. And when that 40%, 20% on the other side of the river, 20% on this side of the river. Logical?
Correct.
This is data collection plan. Now you are trying to cover the entire width of the river along each route. You are trying to cover the entire width, isn't it? Because you know you are going to walk through the complete route.
Yeah.
But at the same time, you have a limitation. You can't measure everywhere. Because there are infinite number of points available along every route, isn't it?
Yeah.
You can't simply tell how many points are there. Infinite. That will be the scenario in many times. But you have some mindset, only 10 points. So 6 points will come from center. 2 will come from the other side of the river, but definitely outside the center. And other 2 will come from this side. And
The voice is not
The
audible.
voice not
Your
audible.
voice is gone.
The voice not.
oh, is it audible now or not audible?
Yeah, audible.
Okay, maybe network connectivity. Okay. So now you calculate the average using the data, and the average for route A, B, and C. All the 3 average are coming to be 4 feet. Now you are the group leader. You have to advise your people to walk through the route. Which route will you suggest? A or B or C?
A.
A.
No, I suggest A.
Okay. So there are different
B.
options coming on, but definitely all
All
the routes
threes.
are not equally safe.
Yeah.
Since the average is equal, it doesn't mean that all the 3 are equally safe. If you really want a correct answer, then you have to calculate, you have to measure the variation. What is variation? the up and down in the root, isn't it?
Yeah.
The ups and downs in the root is the variation. So now first root, let us do a small max here. First root, there are 6 data points. We collected 6 or 7, 6. Now average is found to be 4. Now you are trying to understand the deviation from the center. First point, how far is the first point from the average?
0.
Zero.
Center, 0.
So it is 0. But second point, little more deeper. +1 means more deeper. -1 means, -2 means less deeper.
Less deep.
If you see 0 everywhere, you can even drive your bike because it is flat 4 feet and you will find it a cakewalk, isn't it? You can.
This
you
I have
can
not
enjoy.
understood. X minus X bar.
Yeah,
I have
X
not
minus
X bar.
X bar is average.
Okay,
Difference,
so 4 minus 4, 0. Okay.
difference between the measured value and the average. That is called deviation. All of you understand? Can you see the deviation is not uniform? The deviation is not uniform. Am I right?
Not income.
Yes.
So in order to understand how much is the deviation, we always calculate the average deviation. We always calculate average of the
Average.
deviation. But deviation here is plus and minus. So in order to calculate the average, when I sum up, what is the
Zero.
value you are
Zero.
getting?
Zero.
0. 0.
Doesn't mean that there is no deviation.
Correct.
There is deviation, but the mathematics is now, giving me, leading me in a wrong direction. It is not helping me, Max here. So in order to overcome this, before adding, I want to square all of them. This is called the square of the deviation. Do you now understand why we are squaring here?
Yeah.
If I don't square, straight away calculate the average, the data will mislead me. The data will finally tell me that there is no deviation. Then all the roots are equally safe. But that's a wrong conclusion we are making. So to overcome, we have to square. I have squared all the number. You can see now. I have squared. After squaring, I am summing up. 1, 4, and 4. 1. Now, what is the sum of the squares of the deviation? 6. This value you divide by n minus 1. N is 6. So 6 minus 1 is 5.
5.
6 by 5 is 1.2. This is known as variance. So what is variance? Sum of the squares of the deviation divided by n minus 1. This is known as variance. Since you have squared all the number, the unit of measurement will also get squared. What is the unit of measurement for the depth of the river? 4 feet.
4 feet.
Now,
feet.
what is the unit appearing here? Feet square.
Yes.
Square feet. We
Yeah.
measure building in square feet, isn't it? So
Yeah.
here also it is coming as square feet. So squared unit, sometimes people don't understand. So we are going to take the square root. When I take the square root, I get this value. When I take square root of variance, that now becomes standard deviation. So standard deviation is 1.09 feet. All of you understand? All of you understand?
Yes.
The average depth of the river is 4 feet. 68% of the river will have a depth of 4 plus or minus 1 feet. 68% of the river will have a depth 4 plus or minus 1 feet. That means major portion of the river is going to have the depth from 3 feet to 5 feet. Can you see that, all of you?
Yes. Yes. Yes.
Yes.
Understood.
This is how you can actually start using normal distribution, the knowledge of normal distribution.
Sir,
The better
here's
the quality of the data, better will be the prediction and better will be the decision making. And poor the quality of the data, and you might sometimes make wrong decision, right? Now for the second root, we are doing the same thing. We are doing the same thing. What is the standard deviation here? 1.8.
1.8.
Now for the third root, we are doing the same thing. And it is 1.82. Now the summary is available. Now look at the average, look at the standard deviation and tell me which route is safer. Comparatively safer. It may still be a riskier, but which is comparatively safer?
A.
Root A.
The A1
Simply
question,
because,
sir.
simply because the standard deviation is less.
So
So
one
lesser the
question-
standard deviation, the more will be the trust on your average. You
So one
can-
question
You
here.
can start you can start believing on the average if the standard deviation is lesser and lesser. If the standard deviation is bigger, then your products will have a lot of deviation from the average. Yeah, any question?
Yeah, it also depends upon the number of reading as well, sir. So, so that is what you call as data.
Yeah.
Okay. And there is no limit for the standard deviation. Means it should be 1 or 2 or maybe
No.
0.5. No.
There is
Okay.
no, see, this is something, this is something, a natural
Okay.
phenomena we are measuring. We
Okay.
can't control nature. The depth of the river is the depth. You can't say depth should be this much and that much.
No. I'm not
So-
talking of the depth, but with the standard deviation which we arrived. So, does it have a limit? Means it is just an
No.
empirical value.
It can be any value depending on the
value.
amount of the water in the river. The
Okay.
river can be, if the river is more deeper, then you get more standard deviation. But definitely standard deviation can reflect the characteristics of the river. The average can reflect the characteristics of the river, but for that the quality of the data and quantity of the data is important. And now please tell me, all of you, do you think in this exercise, the data what we collected is, do you think it is sufficient?
No.
No.
Now let us talk, in a very practical way. How much is the distance we said here?
1 kilometer.
1 kilometer,
1
right?
kilometer.
Now
Right.
tell me what could be the ideal sample size or the quantity of the data.
At least every 100 meters you should have the depth.
Every 100 meters, you
should
want
have the
one
depth.
data. That is how 10 data point.
Yeah.
But 10 is not sufficient, right? So every 100 meter, how many data point we can take? Shall we take? See, let us say no, 10 is not sufficient. We feel the risk is more. We want to have more accurate understanding. So 10 is not enough. Shall we go for 30?
50. Yeah.
50. Somebody says
50.
50. Let us go for 50. Now 50. Let me divide the 50 into two parts, 25 and 25. This 25, I will have on one side of the river. Am I logical?
Yes.
Yeah.
From the what do you call the place where you are standing
Center,
until the
no?
center of the river, 25 data you will collect. Remaining 25 you will collect on the other side of the river.
Other side of the river.
That means you are unknowingly you are following property of normal distribution.
Yes.
Symmetrical at the center, isn't it? If you know
Yes.
normal distribution better, your data collection strategy will get better. On one side of the river, you said 50%. That 50%, make sure 34% of it comes, is chosen between the 1 sigma point and the center. That is also a property of normal distribution, isn't it?
Yeah.
So likewise, the more you understand the normal distribution, the moment you also realize your process is also normally distributed, you can apply all these understanding in framing your data collection strategy. And all of you now agree 50 data points sufficient. You have your this side, you are trying to risk your people. You are going to advise them to follow your route. And shall we go for 100? It looks logical here, isn't it?
Yes.
Okay, don't worry
More
about the cost.
accuracy.
Let us measure some more. 50 points on one side of the river, 50 points on the other side of the river.
That side of the river.
But again, going beyond 100 also will look logical if the cost is okay to you. So always the purpose and the cost has to be understood so that you can increase, isn't it? But if you don't know the purpose and if you do not have the clarity about the cost, then probably we simply in a blank manner we talk about the sample size. Don't do that. You should always have an answer. Okay, is this budget, is this cost okay to my current project? And similarly, am I going in a proper logical manner? And what is the purpose of my data collection? And then you will have a clarity. Okay, 10 will do, 30 will do, 40 will do. Otherwise, people always try to follow a thumb rule, which is 30. Right? But again, we are going to give you some useful principles using which you can definitely collect data in a proper manner. So this is the summary of normal distribution. So standard deviation tells you how close or how far is the values of your data are in relation to the mean. Please, standard deviation talks about the deviation from the mean, not deviation from the target. Standard deviation talks about deviation from the mean. But if you
Yes.
want to know the deviation from the target, then you should compare the mean and target. All of you understand my language?
Yes, sir.
Standard deviation tells how far your data set in relation to the mean, right? And mean has to be at the target. And this is the formula. All of you, I think you remember the formula now, right? Square root of summation of x minus x bar whole squared by n minus 1. And here is the normal distribution curve. The pink color area, what will be the percentage? 68%.
8.27.
And one of you, will you now be able to tell me the percentage of the blue color area by looking at the curve?
30.
13.6.
Very good. Very good. Now you are thinking better. Similarly, green color area also you can judge. Some little maths involved, isn't it?
Yeah.
2.1.
Addition, subtraction, we are all good at it. But then that is possible only if we remember all these numbers. But that pink color area is 68.27. Pink and blue, 95.45. Pink, blue and green, that is equal to
99.7.
99.3. And this point is known as control limit.
Controlling.
This point is known as warning limit. This point is known as 1 sigma limit. On right side, it is upper control limit. Left side, it is lower control limit. This is upper warning limit. This is lower warning limit. Now, one of you, please read out this conclusion or the statement. Can you read it louder, one of you?
So 99.73% of the area or points under the curve will lie inside 3 sigma limits. That is extremities or control limits.
Very good. So in any process, the data, 99.73% of the data should lie inside the and the control limits are also known as the extremities. Now, suppose if it happens that your control limit and specification limits are overlapping.
1 second. Maruti, you have
Sir.
any question?
Sir, no question, sir, but I just want a 5 to 10 minutes break.
Okay, please go ahead.
Nothing else.
Thank you.
Yeah, we are stopping here.
No problems.
Okay, you can also go now, no problem. All right. So 99.73% of the area or points under the curve are always lying inside the 3 sigma limit. Suppose if it happens that control limit overlap with specification limit, then the rule applicable for the control limit will be applicable to specification limit also. 99.73% of the parts produced will now get accepted by the customer because you have seen the control limit on the specification limit. If you see the warning limit on the specification limit, what percentage of your products are now accepted?
It is almost warning limit, sir.
That's what. If you see warning limit on the specification limit, what percentage of your products are now safe?
Warning
Simple
limit.
question.
68.27.
95.45.
95.45.
95.45.
If the 1 sigma limit falls on the specification limit on both sides, then what percentage of your products are safe?
68.27.
68.2.
That's all. You
68.27.
collect the data. Even before production, you can speak like this. And your statement will be valid. The quality of the data is valid. Quality and quantity of the data, if you take care of both, then even before production, you can tell how much will be the rejection. Right? Not only production, other fields also, isn't it? It depends on the characteristics we talk about. So now we are able to explain the river. The same manner, if you have proper data, you can also judge on the proportion of the students who will be passing this year. The +2 students passing rate last year, 95%. And what will be the passing rate next year? We can tell because we have every year passing rate data, isn't it? You calculate average and standard deviation, and then you can definitely know every year it is 95, 96 only. So next year also it will be 95, 96. and the standard deviation is very less. So something abnormal happening next year, chances will be very, very less. If 1 year is 40%, 1 year is 80%, then whatever you judge next year, there will be a lot of uncertainty. Isn't it?
Yeah.
So what percentage of the products will be accepted? You did a pilot production. Will you be able to answer this question now? You did a pilot production and now you want to know. After the pilot production, you are going to know, produce 10,000 pieces. Now what percentage of the 10,000 will be within the spec, outside the spec, you will be able to judge. So what percentage of the customers will buy and what percentage of the customer will not buy? These kind of questions all can be answered. Now tell me, average is a measure of central tendency or variation?
Central tendency.
Central
tendency.
Very good. Low standard deviation indicates consistency or inconsistency?
Inconsistent.
No, no.
Consistency. If standard
Consistent.
deviation is
Standard
low,
deviation indicates.
you are more consistent. Variation is less. That means you are consistent.
Ah,
Now next question. Higher standard deviation indicates
Consistency.
inconsistency means more variation,
More
and
variation.
uncertainty. The chances of your decision going wrong will also be very high. The unit of standard deviation
Yes.
is same as the unit of original data. Is this
Correct.
statement true or false?
True.
True.
True. That is why standard deviation is used instead of variance most of the time. The unit of variance will be in squared units of original data.
Yes. True.
This is also true.
True.
Variance is squared value of standard deviation.
Yes, true.
True.
All of you now understand the relationship between variance and standard deviation, right?
Yes.
Square root of variance is standard deviation. Normal distribution is symmetrical about center.
It is true.
True.
Total area under the normal distribution curve is 100%. True or false?
No, false.
False.
68.
99.7.
99.7.
99.
Okay, what is the area under the curve and between the control limits? What will be the area under the normal distribution curve and within the control limits?
That is
68.7.
68.27.
Control
90%.
limit, I am
No,
saying
no, no.
control
It is
limit, I am
sigma
saying
2.
under the curve.
Minus
What is-
0.27%.
Minus 27.
99.27.
Minus
Please, all
0.2.
of you listen to me very carefully. I'll repeat the statement. What is the area under the curve and within the control limits?
99.7.
99.73.
99.73. Now read
73.
this question. Total area
Yeah,
under
it is
the
true.
normal distribution curve is 100%.
True.
True or false?
True.
True.
Total area means you are including even points outside the control
Under.
limit.
Right.
Yes. That is under the normal distribution.
After control limit, it will go up to infinity. We don't know where it goes.
Yes.
Yeah.
Similarly, left side also. Yes, RK sir, you can add.
Yeah, please note, this total area under the normal distribution curve is, when we are dealing in percentage, we say 100%. When we are dealing in probability, we are saying it is 1. When we are seeing in millions of defects, we say 1 million, okay? The total area on the curve will be 1 million DPMO. In percentage, it is 100%. In probability, the total area is 1, okay? Thank you.
All right. So what proportion of points will lie inside control limit? That's the next question.
99.7.
99.773.
99.7.
If control limits stay inside the specification limit, the process is considered capable or not capable?
Capable.
Capable. Specification limits are provided by customer or
Customer.
control limits are calculated using customer data or process data.
Process data.
Process data.
Very good. So that means we have now a strong foundation to understand how to calculate sigma level for any process, any product, whatever we are dealing. So that we do after the tea break. So we stop here.
Yeah.
We'll take a 15 minutes break. So let's try to understand what's exactly Six Sigma with respect to business process. So according to our understanding, Six Sigma is a methodology to reduce defects by reducing variation, to improve the process performance on a particular CTQ. Read the statement again. Six Sigma is a methodology to reduce defects by reducing variation to improve process performance on a particular CTQ. Let us consider this example. So it is like a call taxi company, Ola or a Uber. Now, can you tell me one important CTQ for this particular business?
Time,
So, car arrival time.
punctuality, yeah.
Yeah, car arrival time. Every time a car is booked and the app will be showing a time. Okay, the car will come in 30 minutes. So the car has to actually reach the customer place in less than 30 minutes. That is the goal. So let us talk about a specific problem where the customer expectation is 30 minutes, right? Because every time the different time the app will show, but we are going to talk about only the cases where the expectation is less than 30 minutes. So upper specification limit is 30 minutes. The lower specification limit is 0 minutes.
Immediate, yes.
Practically getting a car in 0 minutes is never going to happen. So let us be a little more practical. So lower spec is considered as 10 minutes. Upper spec is 30 minutes. So in a particular locality, a company is experiencing a problem of lot of cancellation due to late arrival of the car. And actually the requirement is car has to arrive in 30 minutes. The upper spec is 30 minutes, lower spec is 10 minutes. That means they must have a process which can assure delivering a car in 20 minutes. What is this 20? Center point 10 and 30. This is our understanding, isn't it? Statistically, upper spec, lower spec, and then the center point is target. And if you have some arrangement to ensure a car is always delivered between 10 minutes and 30 minutes, you will not have any cancellation at all in that particular region. Am I right?
Yes.
Because the app is always telling, 30 minutes a car will come. So actually car will reach the customer place in 30 minutes. So the cancellations are becoming really 0. So now the situation is visualized. You can see upper spec 30 minutes, lower spec 10 minutes. That means the customer target is 20. And so the customer specification width is the difference between 10 and 30, 20 minutes. Hope all of you can understand everything. It's self-explanatory. Now, with respect to the customer requirement, how is my process? I mean, how is my process operating? So I need data from the process data. Of course, we all know the call taxi services nowadays they capture data, isn't it? The moment it arrives, you have to give a OTP. So that is how they measure the travel time the car is actually taking. So with the availability of the data, an histogram is plotted. You can see the histogram reveals that the process average is 20 minutes and process standard deviation is 3.33. Will you be able to calculate process average and process standard deviation when you have sufficient data?
Yes.
Yes, definitely calculate, right? So process average is 20 minutes. Is this average acceptable to you? Because you want to target 20 minutes, right?
Yes.
You want your process to target 20 minutes. What is it actually doing? It is targeting 20 minutes. That's a good scenario. But standard deviation is 3.33. The moment you know standard deviation is 3.33, calculate the control limit. What will be the distance of upper control limit from the average center? 3 times standard deviation. So 3 times standard deviation will be how much? 3.33 into 3, 10.
9.99.
Yeah, 9.99. So 10, rounded to 10. So process average is 20, upper control limit is 30, and lower control limit is 10. I want to know whether my process is capable or not. So for that purpose, I am going to overlap the control limit and the specification limit. So I have done the overlapping. Now I am also able to see my control limit exactly aligning with specification limit. That means I can make a prediction. What is that prediction? At least 99.73% of the time, my car will arrive between 10 minutes and 30 minutes. Am I correct with the statement?
Correct.
Yes.
That means if there are 1,000 bookings happening, at least 997 bookings, a car will arrive between 10 minutes and 30 minutes. But only for 3 times, the car is arriving either above 30 minutes or less than 10 minutes. Less than 10 minutes is not a problem, but above 30 minutes will lead to cancellation. Are you happy with your process performance? 3 bookings out of 1,000 bookings are under the risk of getting cancelled. Are you happy with the way your process is performing? Or do you think some improvement is required even at this level of performance?
Yes,
Performance
it-
improvement is needed, sir.
Okay.
To reduce cancellation.
Yeah. So as of now, it sounds good, really, isn't it? Because only 3 bookings out of 1,000 is getting cancelled. But still, always companies want 0 complaints. Companies want 0 cancellation. So that means they are keeping some they are thinking about long-term performance. If today the 1,000 bookings a day is happening, and then today there are only 3 cancellations per 1,000 bookings. But what if the demand increases tomorrow? Suppose suddenly the business picks up very well, and if there are 2,000 bookings happening, will we be able to manage the same performance? Difficult, isn't it?
Yes.
Yes.
Damages can be much more than what we are anticipating right now. Currently, we are thinking that our performance is 99.73. Suppose the number of bookings increases by another 100 booking comes, and now your rejection cannot be 0.27. That time, it can be more. Hope you are able to correlate, isn't it? So
Yes.
that's why it is always, keeping your the performance little better than the actual requirement. It is something like, imagine you earn a salary of 1.5 lakhs and your wife is spending all 1.5 lakhs in the same month. You still look capable, isn't it? You are not keeping any dues, but still you are in a dangerous condition, isn't it? So if you make 1.5 lakhs and then if your wife can spend little lesser than that, then that additional money available will act as a cushion to meet any unforeseen scenario, right? And that's why, the higher capability is recommended. So now the process is just capable, I would say, just capable, and the success rate is 99.73. How much is the success rate? 99.73. Let me write it here. Do you understand where from I am getting this number? From normal distribution only, isn't it?
Yes.
Because control limit is overlapping the specification limit. The success rate is 99.73 and failure rate is 0.27. But I also know that this is only a short-term capability. In the future, my company might get additional bookings, not 1,000 always, isn't it? In the very near future, within 3 months, my business will definitely increase. From 1,000 booking to, it can go to 1,200 booking, 1,300 booking. At that situation also, I don't think I will get same 99.73. That means this capability of 99.73 is only a short-term capability and not a long-term capability. So this situation is known as just capable. Why do I call it just capable? My control limit is already touching specification limit. My control limit is already touching specification limit. Look at your specification width, which is 20. Look at your process width, that is also 20. Find out the ratio. That ratio is known as process capability index. CP, CPK, we will be discussing. So CP, CPK is equal to 1. You know why it is 1?
Both
Specification
are
width
same. Specification same.
and process width. To calculate specification width, the formula is USL minus LSL. Formula is USL minus, I write here, USL minus LSL. This is specification width. Process width, what is the formula?
Same. UCL minus LCS. Upper control minus lower control.
But what is the distance of upper control limit from the center? 3 sigma.
3 sigma.
What is the distance of lower control limit from the center? I expect a quick answer here because this has been discussed before T. So specification width, I'm comparing against process width. And both are same in this case, right? Specification width is USL minus LSL. Process width is UCL minus LCL. Both are same. So this is equal to 1. That's why I consider the process as just capable. And this is known as CP, capability index. CP equal to 1. specification width divided by process width. Both are same. So my process is just capable and the success rate expected is 99.73. But this is only a short-term success rate. And I'm going to give a nickname to this process. And even before going to the nickname, let us find out the sigma level. Now, please look at the slide and tell me how many sigmas you are able to fit in between the process center and the nearest spec. How many sigmas you are able to fit?
3 sigma.
3.
3 sigma.
Process is known as 3 sigma process. Because if at all any failure happens, the failure happens on the right side or happens on the left side. Because most of the process, the tolerance will be sensitive on both sides. But here it is not sensitive on the left side. But generally in manufacturing or even in many other scenarios, the process can be sensitive on both sides. So center to nearest spec 3 sigma. So the process is known as 3 sigma process. And now let me give a nickname to this. And it is an elephant process. And why do I show elephant here? Because you have fitted a process occupying the complete tolerance given by the customer. Can you see that, all of you?
Yeah.
The very beginning of the discussion, we understood that no, the elephant should should have a bigger tub. But here customer tolerance cannot be altered. So you should only think of having a smaller process. I mean narrower process. But your process is very wider to the extent that control limit is touching the specification limit. So this is as good as having a scenario where elephant and tub are same, equal size. So you are creating a challenge. You are putting yourself in a challenging scenario. You can't expect an elephant to stand still in a room which is equal to the size of the elephant. Do you think any elephant will stand still? It will definitely break the wall, and then the damages will happen. The same thing is possible to your process also. So always when you design a process, don't design in a way that control limit is on the specification limit. Ensure your control limit is pushed well inside the specification so that you are giving your process some room for variation. Hope all of you understand what I'm speaking. So this is a different process. And now the red color wedge on the right side indicates your rejection. I'm not indicating rejection on the left side because it is not applicable to this process called taxi service. Rejection is only happening on the right side. And what is the percentage of rejection? 0.27 divided by 2. Am I right?
Yes.
0.27 divided by 2. But you know what happens in a long term? Like I told you, the elephant will break the wall and move. Same way, can you see your process is also moving to the right or left?
Right.
Right.
Yes.
In this case, it is excellent. But actually what happens is your process is moving to the right. That means what happened? Slowly after 3 months of service, the cars have become little old. The drivers, they started not adhering to the SOPs very perfectly. There are chances, isn't it? And so because of that, though you at the time of starting of the process, everything went on extremely well. Now the process is completely shifted. Now all your cars are taking extra time. It's not just targeting 20 minutes. It is targeting something else. Can you see that, all of you?
Yeah.
Yes.
So a process,
Half of the process is shifted from the
Yeah.
center.
in a short term, the process looked really capable, but now it's not capable. There are a lot of cancellations happening, and you can see as the process center is shifted, the control limit also will shift. Control limit will also shift, and now can you see the rejections now? Rejections are not 0.27 by 2. Can you see the rejection now? It is
Yes.
more than 10%. This is
Increased.
called 5% rejection, 10% rejection we talk about. So considering the shift, considering the long-term capability, the success rate is not 99.73. It is less than 90%. When your process is having a success rate of close to 100% in the short term, the same process in long term may have a success rate of less than 90% and rejection rate of more than 10%. So that's why 3 sigma capability is not sufficient, not enough. All of you understand why we are talking about higher capability? So we move on.
Sir, one question. Sir, Uttam here. One question, why it is moving only right side only?
Yeah, it can move to the left side also, but in this case, left side is not applicable because moving to the left side is really good for your process,
Okay,
right? Your cars reach very fast to the customer's place, and that is actually good. So that's why we are not considering the shifting to the left. Only when it is shifting to the right, it is problematic. Otherwise, it's not a problematic case.
okay, sir.
Okay, so now we understood something that our long-term capability should also improve. So as a result, how can I improve my long-term capability? Can you give me some light, some input to improve my capability? What can I do? I'm running a call taxi business. Can
So
all
you
of
have
you
to
give
squeeze
some
your
suggestions?
timeline. You have to squeeze the response time.
Okay, I have to reduce the response time. So what should I do practically? How can I increase? I mean, how can I decrease the response time?
So we should have good set of cars.
Scale of operation.
What is that? Scale of operation.
Increase the number of cars.
Scale of operation. Increase the number of cars.
I agree. Increase the number of cars so that you can have cars in different places. So cars can now reach faster. Isn't it good idea? What else can be done?
The existing car to be serviced regularly, so they less
Very good.
waiting time,
Some
downtime, breakdown.
Periodical
Maintenance.
scheduled preventive maintenance is implemented. Isn't it?
Maintenance. Yes.
Periodical, scheduled, and preventive maintenance is implemented. It is made mandatory.
Right.
The car must be serviced once in 3 months or once in a month, and then along with the tire check, etc., etc. Checkpoints. Very good. SOP is upgraded now. Very good. What else can be done?
Sir,
Less
one more
breakdowns.
point is like we have many waiting points where the cars can be spread across the city based on
Very
the data where we can expect more number
Correct.
of bookings. That is another point.
Excellent point. We can study where from more bookings are coming. Let's allot more cars in those areas because more bookings are coming from certain prime locations, and those locations will have more cars. It's not simply keeping car everywhere. No, the more cars in demanding area and less cars in less demanding area. Very good. Good idea. I think all of you now understand how to improve the process capability, isn't it? So now we really improved. Since you added more car, you take care of the maintenance, and then you allotted the cars in a very systematic manner. That will reflect in your performance, and so will reflect in your data, and so will reflect in your statistics. Now let's have a look at our statistics. Look at our process average. Is again brought to 20. Can you see that? The
Yeah.
process that was shifted is again brought to 20. But look at our process standard deviation. Just 1.66, which was earlier 3.33. That means our process has now become more consistent. Now with the revised standard deviation, calculate the revised control limit. Look at the control limit now. Upper control limit is this time is not 30. This time it is only 25. Now you are able to see your control limit well inside the specification limit. Can you see that? You give 1.5 lakhs to your wife, and your wife is not spending the entire money. She is spending very carefully and then spending only lesser than that. That's why your control limit is staying inside, right? So now let us see. Okay. So now if you consider the performance is earlier we thought it is 99.73, but this time it is 99.999%. Look at the success rate. If there are 1,000 bookings happening, almost all 1,000 bookings car will reach on time. The chance for delayed arrival of the car is very, very, very rare. 0.001 is the chance, right? You improved a lot. And now look at your specification width and process width. Can you see? Process width is just half of the specification width. That means your process has now become doubly capable. Though you give 1.5 lakhs, the monthly expense is how much? Only 75,000. Even if you don't get the salary next month, still family will be run, very smoothly. No problem. So that's the advantage of having, higher capability. In this case, it is doubly capable. In terms of sigma level, the same method. How many sigmas you are fitting between the nearest spec and the process center? How many sigmas you are seeing here?
Six sigma.
Sigmas.
Very good. 1,
Six.
2, 3, 4, 5, and 6 sigma. Remember, the center is at the same point. Specification limit is at the same point. Then what has changed now? Sigma is reduced.
Control limit. Control limit.
Sigma.
Control limit changed. Why? How control limit changed? Sigma reduced.
Sigma reduce.
That's why you are now able to place 6 sigmas. Right? Now you are able to place 6 sigma. So this is a 6 sigma process. Right? And success rate is 99.999. And I'm going to give a nickname. This time it is not an elephant. This time it is giraffe, because I could see the curve taller. If many points comes closer to the center, control limit coming closer means many points coming closer to the center. As a result, the center will become taller. If you see all these things happening in your normal distribution curve, and you can understand your process capability is going high. So now this is a giraffe process, doubly capable process, 6 sigma process. Success rate is 99.999. And this is not just short term, this is a long-term success. Why? In a long-term process will tend to shift, isn't it?
Right.
I am just shifting the process.
Mm.
See by how much distance I am shifting. I am shifting
2
by a
sigma.
distance equal to 1.5 standard deviation. Can you see that? Can you see the control limit moving by
Yes.
1.5 standard deviation?
Right.
This is a statistical, estimation. Generally, any process will shift by a distance equal to 1.5 standard deviation. But even after shifting, can you still see some additional cushion,
Yes. Yes.
tolerance available? That means even then the failure is not happening. Even if my process is shifting, then also it is difficult for my customer to find a problem with my product.
Right.
Right? But if something happens here, because it is found beyond the control limit, we are going to take action. That means we have now become proactive. Earlier, we take action only if something happens here. But now we started taking action when something beyond control limit happens. And in fact, our control limit itself will be here only. Only when the process is under the influence of some special cause, my control limit will move. There itself, I will take an action. But even then, those products will still be safer to my customer, right? That's the kind of capability you have achieved now. Now, anything that is going beyond the control limit, yes, that will be considered a failure. In a company where 6 sigma belts are available, or the culture itself is 6 sigma, they will clearly understand any observation outside the control limit is a major deviation. They will start taking action, isn't it? But however, to my customer, failure is seen only here. Can you see that?
Yes.
Yes.
That is what is 3.4 DPMO. That is what is 3.4 DPMO. And now, let me just check your understanding. Now look at the graph and tell me, is it looking like an elephant or a giraffe?
Elephant.
Elephant.
Alpha.
And statistically, what is the sigma level?
3.
3 sigma.
3 sigma. And what will be the success rate you can expect from this process?
99.73. 99.79.
99.7. And now, this is a short-term success or long-term success?
Short term.
Short term.
Short-term. In long-term, the damage can be more. And look here, I have written something, G-score. The G-score here is a G-score represent measure of capability here. G-score is a measure of capability. G-score simply means the number of standard deviation between the process center and the nearest spec. If you have more G-score, the process is more capable. Hope all of you understand.
So
And
is
now,
it the sigma level? G-score means?
yeah, this is the sigma level. Yes.
Okay.
G-score is nothing but sigma level. When we say 3, it simply means, there are 3 standard deviations that can be fitted between nearest spec and the process center. When I say sigma level 3, the success rate is 99.73, the short-term success rate. Now coming on to the other process. Now how it looks? Is it still looking like an elephant or a giraffe?
No, giraffe.
Giraffe.
So in terms of sigma level, I'm showing you sigmas here. What is the sigma level here?
6.
6.
Sigma.
Six.
Sigma.
So what will be the success rate here?
99.99.
99.999.
99.999% of the values. It can be any number or within the spec. And is this value a short-term success rate or a
Long
long-term?
term.
Long term.
Long term.
Term.
Beautiful. Because why do we call it long-term? Earlier, the 99.73 was calculated using a G-score of 6. But now what is the G-score used?
4.5.
4.5. Because we know in the long term, my process will shift by 1.5. So 1.5 standard deviation, I'm not taking into account. So for a G-score of 4.5, a minimum assured success rate is 99.999. That's how this is speaking about the long-term capability. And again, process can be one-tiled or process can be two-tiled. In the call taxi service, the process is one-tiled. Only right side it is sensitive. And so the success rate will be 99.999, 666%, little more. So DPMO will be 3.4. But for a two-tiled process, let's say you manufacture a food product, or you are maintaining a sugar level or a diabetes level, it is sensitive on both sides, isn't it? We need to maintain our sugar level, cholesterol level, no, within a range. Right side, when you cross the right side, that also leads to a health problem. Left side also, that leads to a health problem. So two-tiled process means the tolerance is sensitive on both sides. So now the success rate is little lower than the previous one. And so the rejection rate will be 6.8. Can you see 3.4 here?
Yeah.
This is the benchmark performance suggested by Bill Smith and Michael Harry of Motorola. They did all the calculation and simply gave this data to us. Performance where the DPMO is less than or equal to 3.4 is known as Six Sigma. So now,
Sir, one question here. So just you made a mention that Z score is 4.5 for when the curve became narrower. So is there a way which we calculate this Z score?
yeah, you can calculate here in the curve. Let me take you to curve. Yeah. So here it is 3 sigma, right?
Yes, sir.
So G score, the formula, you take this distance. What is this distance?
3 sigma.
This distance is, yes, 3 sigma. And the other way of finding out the distance is X bar minus LSL. Am I right?
Okay.
You divide this by sigma. Then what will be your G score?
Average is
Left side, it is X bar minus LSL. When I divide by sigma, what will be the answer?
3.
Very good. That is the G score.
3 minus.
Similarly, on the right side also we can calculate. Right side, it will be USL on the right side. Center will be X bar divided by sigma. If a process is centered properly, both right side and left side will have the same G score, right? So it is always good to have a process centered properly. So don't worry, we will be coming to these formulas again, where we will talk about CP. Like see here, I have written CP equal to 2. You know why CP equal to 2? Your process is made doubly capable here, right? So we'll be talking about it again during the baseline performance. So the G score, the definition is nothing, simply take one half of the one side of the process from the center to any one nearest spec. Try to find out number of standard deviation. That is sigma level. And mathematical formula also I have given. The distance between the upper spec and the center. Center is X bar and right side it is upper spec. See here the distance between upper spec and center. USL minus X bar. When I divide by standard deviation, I come to know number of standard deviation that can be fitted. That is known as G score. All right. Is that doubt cleared, Mr. Naveen?
yes, sir.
Okay, very good. So when your process is having a too much variation, look here, it looks like an elephant head. So it is hard to produce output meeting customer requirement. Under such situation, sigma level will be low, yield will also be low, but defects will be very high. When the variations are less, process will look narrower. That means it look like a giraffe. So virtually everything you produce can meet the customer requirement. sigma level will be very high in the order of 4.5 to 6. That means success rate or the yield is high and rejection rate will be low. So that's how this is called a Six Sigma way of problem solving. We understand the problem through statistics and we solve the problem through statistics. So in order to understand the problem, we convert the real-time problem into a statistical problem. Real-time problem means products are not good. Statistical problem means average is very high. Statistical problem means standard deviation is very high. Do you understand? Can you talk in terms of statistics? My students' performance is very bad. As a teacher, I'm saying that my students' performance is very bad. This is real-time problem. The class average is less than 40. This is reflecting the same problem, isn't it? The class average mark is less than 40. That means my students are not performing well. Same manner in your industry also, in your business also. Can you talk, can you express your problem using a statistics, particularly average and standard deviation? Average means it is below target. Below target is a problem. Standard deviation means when the variation is more, the results will be more inconsistent. When the inconsistency is more, gradually control limit will stretch out, isn't it? As control limits stretch outwards and then go beyond specification limit, and then your business will be under heavy risk. Your profit will, it will start eating your profit. So that's why this is called a Six Sigma way of problem solving. Any real-time problem can now be converted into a statistical problem. And then for statistical problem, there is a statistical solution. What is statistical solution? Move the average to the target. Move the average to the target. That is what we want. Standard deviation, what do you want to do? You want to reduce standard deviation or you want to increase standard deviation?
Reduce.
You want to reduce standard deviation, that's all. So this is called a statistical solution. But when the standard deviation will reduce? Only when you take right actions. Isn't it? Only when you take right action, standard deviation will reduce. Only when you take right action, your process average will move towards the target. Am I correct or not? Nobody can move the average, physically. You can move the average only by taking right actions. Whether your project is really making the right changes or not, then only it will reflect in the statistics. Otherwise not, right? So that's why this is called the Six Sigma way of problem solving. You can solve any complex problem and definitely result is going to happen. All that required is a proper, combination of team members. Six Sigma bells have to participate, and then there has to be, proper support in the environment must be supportive. Then definitely we can deliver result. So the benefits, the revenue can go up, cost can come down, the resource efficiency will go up, and importantly, the people in your organization will become more and more knowledgeable, more and more effective. You are able to think wisely now. Can you see that, all of you? So the more the number of bells in your organization, more knowledgeable will be your organization. If people are effective, your organization will certainly be effective, right? And that means you can see the culture spreading. One belt produces more bells, and the knowledge sharing happens, and everybody is, now becoming a Six Sigma belt. That's how a great culture is developed. So now you can read all these lines comfortably. Sigma level is a measure of process capability. Specification limits or the tolerance limits provided by the customer. Control limits or the tolerance limits calculated using process data. A 3 Sigma process is just a capable process in which the short-term yield is 99.73. A 6 Sigma process is a doubly capable process in which the long-term yield is 99.999%. In a 3 Sigma process, the control limit will overlap with specification limit. In a 6 Sigma process, the control limit will stay at midway between process average and specification limit, making your process doubly capable. Higher the Sigma level, higher will be the capability. Higher the Sigma value, lower will be the capability, because Sigma is variation, which is unpreferred. Hope all of you can understand all the statements, isn't it? Yes?
Yes.
Yes, sir.
That's all then. Now you can collect data and then you can calculate a baseline and but now you understood how important it is, to have a proper quality in our data. Any error you accumulate during measurement will obviously affect your statistics and all your understanding will go wrong. That's why, you have to understand the data and then understand your measurement system, and you should have the right people doing the right job for you and then bring the data. Otherwise, your data will, will not, reveal anything. So that's the point. Okay, any questions you can ask and RK will answer.
Sir, good afternoon. Yeah, Prabhakaran here. So, as far as new process is concerned, can you help me that how can we arrive the USL LSL, sir? But it's not defined. So, since it's
For
a
new process,
yeah, new process, it's a new plant. Let's say it's a greenfield plant or whatever may things.
Uh-huh.
How can I set up the USL LSL?
Can I come, sir?
Please, sir.
In a new process, can you identify the problems?
So, sir, first I
Who
want
is there
to.
who is there to give you the problems? Is there customer? No customer.
Okay.
Is there a business? No business. You will neither have voice of customer nor voice of business. So there is no problem available. So what you'll have to do is you'll have to start designing. So first start designing for Six Sigma. That is called design for Six Sigma. Okay. That is, you anticipate problems. You go for market survey. What do they want? How will you provide that? So all these questions you ask and then start designing it and then do your YY analysis within, right? So that is design for Six Sigma.
Yeah, correct, sir. Thank you, sir. But as far as now is concerned, Greenfield project has completed and it has been started very recently. For 30 to 40, nearly 3 months we have operated. So
very good.
We are,
that means you have customer, you have the business.
yeah, correct.
Ask for voice of business, voice of customer.
Okay.
And go for a gumbo walk. Do it yourself or get the help from the customers and the subordinates.
See, customers need not be always end user. If you are not receiving the voice from the end user, you can use the internal customer's voice, isn't it? Process requirement and see, always there will be customer requirement, but sometimes we the thing is, we may not be able to interact with the customer. It doesn't mean that the customer requirement doesn't exist. You get my point?
Yeah,
we don't know the customer requirement. It doesn't mean that customer do not have any requirement.
Okay.
Customer definitely have requirement. Only thing is you have not interacted.
Okay, sir.
Customer expect you to meet the requirement.
Okay, sir.
You have to
only for June, sir, or YTD, sir? Till
only for.
Okay, sir. Okay, sir.
Sorry, some distraction.
Yeah. Okay. So that means the requirement has to be defined internally. You define the requirements internally and then, you through that you try to meet the, let's say your wife is asking you to buy some vegetables from a nearby shop. She doesn't tell the exact quantity. What will you do? If you ask again, she is going to shout you. She is not allowing. Hey, you do it yourself. Will you be able to do it yourself?
No.
Then you come back with empty hands. She will not allow you inside.
Okay.
You have to now judge, isn't it?
Yeah.
So how much is required? So sometimes this kind of exercise you have to do. Right?
Yes, sir. Understood. I will be recapping the things. First, I want to go for the initially set up things like a roster or something, the process assessments. I want to have some default process. Then I want to put into the capability part, histogram. Then it will give some ITROs for me, I believe.
Yeah. See, sometimes
the order is there, structure is there, sir. But then within the structure, we will have to use our creativity. Understand? We will have to, because there is no such procedure like this is what I have to do. Like, for example, this lecture you consider. I'm giving you a lecture. My lecture may be good or may not be good, but you can tell me yes or no.
Yes.
All of you can tell me that RK's lecture is good or bad. And if it is good or thing, I will improve upon. On either case, I will have to improve upon. Yes or no?
Yes.
Right. So now I have some data. Consider what is that I did in my first lecture. Nobody has given me that my lecture is good or bad. Then what did I do? That is called design for Six Sigma. Yes or no?
Yeah.
Clear? That is what I do initially, whether you want it or not, you have to do a design for Six Sigma. Whether it may not be for Six Sigma, it may be for Three Sigma. That's all. Right? Or it may not be for Sigma at all. It may be a hopeless lecture. My lecture might have been, it was a hopeless lecture. You ask Gopal Shivakumar, he used to tell me, sir, don't do it, please. Right? But nobody followed my lecture. Then what I did, then I stopped. So it was like trial and error method in my case. But I am now teaching you Six Sigma. Why I am teaching you 6 months? Because that is more valid approach. You will get the solution correctly in the first attempt. All our aim is only to do it right at the first time. First pass yield should be high. Okay. Thank you.
So the point is, if customer has not given you the tolerance can be defined internally. Right? And then you get an idea about specification limits, and then you will work accordingly. But when you yourself define the specification, you should be very careful that you are not disappointing your customer. You have to be very proactive. Yeah.
Okay, sir. In this case, if I am setting the specification limit, so by means of running the control chart, I would be able to understand that whether the specification limit is fitting or not. Then I would be revisiting the specification limit, right?
When you are defining tolerance internally, it is based on your past experience.
Yeah, correct.
Right? But control chart will only tell you whether your process can meet, whether your process is operating normally or not. That is what control chart will tell. Because control chart has no role with the specification limit.
Yeah.
Control chart will only work according to the control limit. We will talk about it. We'll talk about it. And during the control, we are going to talk about it.
Yeah. Thank you, sir.
So can I come? Somebody was asking the difference between sigma and Z value. Sigma
Yes,
level
sir.
is nothing but Z value.
Okay,
Z
sir.
value gives the performance level. Performance level should be high. Yes or no?
Yes, sir.
Right. And sigma is deviation. Deviation should be low. Yes or no?
Yes.
And the lower the deviation, higher the performance. And therefore related. And this relation, we purposely tell you don't bother, because if I start teaching you, you will hate RK. It is a mathematics. It is called statistics. Mathematics at least is easy subject. Statistics is much more difficult subject. But I make this easy for you and give you templates. Don't worry. Right? How is it related? What is the formula? And all these things. Understand?
Okay.
Like it is like this, no? If you get less than 30 marks, what happens? You fail. Yes or no?
Right. Yes.
You get more than 90 marks, you get what? You get honors. Yes or no?
Yes.
And honors is high level performance. Right? Pass and fail is Z values. Performance should always be high. And the marks deviation is this 30 marks, the marks that you score from 100, the deviation, right? The deviation should be low. That is from 100, it should be 1 deviation means 99%. 100 deviation means 0 marks. So the deviation should be low, performance should be high. Keep that in mind. That is enough for you. But by the end of the course, I promise you that you will get all the ins and outs of this data yourself, and we'll give you whatever you want. We will give it to you throughout your lifetime. Don't worry. Right?
Yes. Oh.
Very good. So, okay. So now we will move on to the steps and tools inside Measure Phase. So